Okay, everyone. I'm really pleased to welcome everyone to this year's Arctic Day. It's the fifth of in its kind. My name is Brit Skjelkvåle. I'm a chair for the Arctic Committee here at the University of Oslo. And this Arctic Day is something we organize every year. And this year it's in collaboration with the Department of I must find it here. It's a long name. Norwegian Institute for Maritime Law, of course, with Olav Mestad is here, and the Science Library, in which where we are just now. The University of Oslo, maybe you don't think about the University of Oslo as an Arctic university, but we do a lot of Arctic research in all parts of our university. And in total, we do have a large publication rate, as large as the other universities like Tromsø and Bergen. But it's, and therefore we have this Arctic Day each year to highlight all the good research which is done within Arctic research at our university. And I'm really pleased to see that there are a lot of colleagues from University of Oslo, but there's also friends from other parts of other departments, other institutions. And I will particularly mention, since we have a very good cooperation with UArctic, University of the Arctic, that the president of UArctic, Lars Kullerud, is here today. So today you will have a taste of research from biology, geology, oceanography, history, political science, law, social geography, and economics. And we will learn about the first Scandinavian marine researchers and draw a line up to the governance and cooperation related to the seas. So an important message now is that this is live streamed. That means that everything you say and do here will be streamed, and everyone else outside this room can see it, and it will also be put on our YouTube channel so people can see it later. We have two presentations now before lunch, and then we have a longer lunch so people can mingle and talk, and then we have several other presentations after lunch then, and we will end about 6:30. That's the plan. So I think I have said all the important things that I need to say before I give the word to our rector, Svein Stølen, that will give an introduction to the day.
So, thanks. It's a pleasure to be here. I need to switch glasses, of course. Age. Dear friends, I'm very pleased to welcome you to this fifth Arctic Day of the University of Oslo. And as you all know, we do have a proud history of researchers exploring the Arctic here at the University of Oslo. Fridtjof Nansen being the most famous, not only University of Oslo, of course, but also Bergen Museum. His research was important also for the young nation, I would say. But he also, together with his academic curiosity, sparked the development of modern dynamical oceanography. In addition to starting the Oslo School of Neuroscience, in addition to working with European refugees that earned him a Nobel Peace Prize. And of course, Vilhelm Bjerknes, whose theoretical work led directly to the development of weather prediction. This very building is named after Vilhelm Bjerknes. So today we find Arctic research and ocean science within many disciplines, as Britt-Lisa said, at 4 faculties, at 2 museums at the University of Oslo. And this is really the motive for, how to say, join forces on this Arctic Day, or opportunity to gather relevant researchers from throughout the university, as well as curious stakeholders from outside. I'm happy to have visits also from outside the university, of course, others that are interested in the Arctic. This year's topic is Arctic Ocean Concerns and Consequences. And this is extremely fitting, of course. We have entered the United Nations Decade of Ocean Science for Sustainable Development. And the ocean is definitely on the agenda globally. The International Ocean Panel is one important initiative launched by Norway to achieve sustainable ocean management worldwide, with Prime Minister Jonas Gahr Støre as the co-chair. And here in Norway, the new government, the former position as Ministry of Fisheries has become the Minister of Fisheries and Ocean Policy, highlighting the importance of this policy field. And not without reason, of course. The ocean has always been extremely important to Norway. It has shaped our industries, our economy, our foreign policy, culture, identity. Our sea area is 6 times as large as the mainland, and more than 200,000 people work in oil, seafood, maritime industries, and contribute to value creation of around 500 billion Norwegian crowns annually. In the most essential respects, the ocean provides goods and services that are fundamental to life on Earth. And the ocean is still rich and mysterious. There is still much we do not know about the ocean. Some of the knowledge we do have was uncovered for not that long ago. Like one day back in 1986, when something strange appeared in the lab of Sally Kissel and her colleagues at MIT. They were looking for undiscovered marine organisms and had decided to resort to a new technique using lasers to count and sort cells. And when they did so, an unexpected and red glowing signal appeared on the instruments. At first, it was so faint that they thought it was some mistake, that it was a technical challenge. But it appeared not to be a technical problem. Kissel and her team had discovered that tiny bacterium. As small as it is, there's about 3 quadrilliards of it in the ocean. And nerds like us, quadrilliard is a number with 27 zeros behind it. So it's a huge number. And this microscopic organism contributed to the emergence of life on ocean, to the process by which the amount of oxygen in the atmosphere began to rise a long time ago, resulting in life on land as well. Today, this bacterium produces 20% of the oxygen that we breathe. Every 5th breath is coming from this organism. The Arctic Ocean is a delicate mesh of intertwined organisms and biological processes. Take the marginal ice zone, which is the area where open sea meets Arctic sea ice. For more than 3 million years, this so-called food tray has been home to a unique diversity of life, such as plankton, fish, seals, birds, polar bears, whales. Being so complex, the Arctic Ocean is also vulnerable, which makes us as a society vulnerable as well. Those that will understand should try to understand the Earth. They should also try to understand the ocean. That was a quote by Nansen once upon a time. We see that most acutely with the climate change. The Arctic is warming much faster than the global average, 3 times as fast. As a result, an increasing share of the Arctic is free throughout and during most of the year. This opens up human activities such as fisheries, transportation, tourism, petroleum exploration, with all its pressures on nature and environment. This creates a new reality. The recent development with so many different industries competing to make use of the ocean, traditional ones and new ones such as ocean wind, ocean fish farming, seabed mining, induces new challenges and require consolidated and knowledge-based ocean management. Achieving this is no easy task, of course. The Arctic area is regulated through several treaties, conventions, and agreements, but also the jurisdiction of 8 different countries. So, how to proceed? I would like to highlight the trust that characterizes the Nordic countries. It's crucial for cooperation across sectors and borders and vital for dealing with conflicting interests related to the ocean. This trust must be safeguarded at a time where we see signs of more polarized debates and politics, really. After all, the balance between growth and conservation will not be less challenging in the years to come. As a comprehensive university with a wide range of disciplines, the University of Oslo has particularly good prerequisites and the capacity to address such interdisciplinarity and highly complex issues that relates to the management of the ocean. We have cutting-edge expertise on climate change, its consequences for resource situation, politics, security, legal issues, biodiversity, and the people living in and of nature. By understanding what is happening and why it is happening, we will be more equipped to deal with the changes that are coming and to handle them in a sustainable way. Thus, research and knowledge is still in need, and University of Oslo will do its part, not at least because of our scientists also present here today. So with this, I really are looking forward to listening to the first lectures, at least as a rector, but I wish you good luck with the whole conference. I really believe this is an important conference for University of Oslo and for the nation. So thank you so much, and good luck. Enjoy.
Mestad. He's also head of the Norwegian Institute for Maritime Law. And Ola has a very, very long CV. And to put it very short, he's worked extensively with oil and gas law, both as an academic and in private practice. He also been chair of the Council on Ethics of the Norwegian Government Pension Fund Global, the Oil Fund. That was in very short, Ola. But you will take us through the ocean research position paper from the University of Oslo.
Thank you very much. It's a pleasure to be here up at this campus, coming from downtown, of course. My talk is called The Ocean Research Strategy of the University of Oslo in the UN Decade of Ocean Science. And do we have a strategy? Not quite sure, but since we have Rector here, we can develop this thinking a bit further. There is a need for university ocean strategy, and that's what I'm going to talk about, and related to the position paper that Brit-Lisa mentioned. I don't have to go too much into how important the oceans are. They are crucial for the way that the planet and people will develop. Everyone knows that. But there's an extreme lack of knowledge about the oceans, as we also know. And that's why the UN has declared the Decade of Ocean Science, of course. The research that is needed is interdisciplinary and multidisciplinary, not because those are buzzwords currently, but really because understanding the oceans and managing them needs interdisciplinarity. And what I state at the bottom of the page may be not completely true for all the Arctic researchers, but I say anyway, the Arctic is very much a special case of ocean research, just sort of part of it in a way, or a special focus. So what I'm going to talk about is more generally the need for an ocean strategy. And the starting point of this is the University of Oslo position paper on ocean research. What the university did in June was to submit the position paper to the Ministry of Education and Research. And you can find the link here afterwards. It was developed by Professors Katrine Borgå and Atle Jensen from Bioscience and from Mathematics together with me. So it was interdisciplinary the way we were working. And we talked to or emailed with or discussed with more than 50 researchers at the University of Oslo. What we really tried to develop was bottoms-up thinking about what sort of ocean research that was needed. We talked to people on all faculties, many institutes. We also talked to people outside of the University of Oslo. This is not exclusively a University of Oslo thing, but our task was really to think through what should the University of Oslo do in this field. And I think that this position paper may be a basis for an ocean research strategy of the university. We can build further on that. So what do we say in the paper? We say many things, but what we did was to select or point to 6 different areas which we find especially important for ocean-related research. And these are these 6 here. And as you can see, they are partly interdisciplinary within natural sciences, or between different sorts of natural sciences, and then also across to policy issues, law, etc., business-related issues. So we've given them these names, and I can't go into the different details here, of course, because then it'll fill the whole conference. But the first one is from genes to ecosystems. So it's some sort of a biological idea from the smallest parts to how the whole thing is functioning. The next point is physical oceanography and hydrodynamics, which is really, as I understand it, that's part of the whole thing, and lawyers should understand this so that everyone can accept it. It's really about waves and about how the oceans move, basically. Then the third point, ecosystems under pressure or under influence, has to do, of course, with pollution, but not only. It has to do with all impacts, climate impacts on ecosystems, not only oceans' impact on the climate. Then there's a point on business-related research. That's how to develop fish farming, for example, ocean wind farms, etc. And then the second last point, which is very close to my heart, being a lawyer, because it has to do with management or governance of the oceans. How do we really, based on this knowledge that we partly have, partly need to develop further, how do we manage the oceans? That's extremely important and complicated. And then the last point, which is about interpretation and understanding of the ocean, meaning Norway is really a land of the sea. And it's been crucial in Norwegian literature, even in music, for example, and in history, of course, to understand the impact and importance of the oceans. So these are the 6 selected areas that we've pointed to, not necessarily having to be undertaken by the University of Oslo only, because this is meant for the government's planning of research. What characterizes these chosen areas? They are, as I already said, interdisciplinary within and across the main disciplines. And examples, of course, were bioscience, geology, mathematics, informatics. One of the really funny things about working in this group, trying to talk to 50 different scientists and everything, is all the strange things that you discover that someone wouldn't know about at the university. That's fantastic on its own, actually. But anyway, you see the different examples here. Oceanography, meteorology, of course, relate to one another closely. Climate, but then also bioscience, which is related to fish farming. What should you farm? Or ocean farming more in general. And then natural sciences related to political science, economics, law. And these are just examples of how we looked at different disciplines when we pointed to these selected areas. Why did we do this? Why did the university choose to establish these position papers? They were developed as input to the government's long-term research plan, Langtidsplan for høyere utdanning og forskning, which is the white paper number 4, 2018-2019, by the Solberg government. And what did we see, or how were our reflections related to what the government focused on? The government had put up oceans as the first priority, the first selected area of its research plan. So we're very much in line with the thinking of the former government when we looked into the oceans. But in our opinion, the long-term plan was over-focused on business-oriented applied research. It was too much on business development, or at least too little about the basis for this business development. And the plan also ignored very much the close relationship between fundamental research and business development, because it's not so easy that you just do applied research and then you develop all sorts of businesses that you need to develop, because very often you won't understand really the circumstances in which that business will develop, or what the consequences of that will be. And also the plan ignores completely the role of the humanities, which is a bit strange in a country where Norway really, where the name of the country means the road along the sea. So I mean, it's not national enough in a way. Oops, whatever. So that should also be covered. in the research. And just one example of these 6, the one that I said is close to my heart, which relates to management and governance of the oceans. What's really the point? Under national jurisdiction, the management of the ocean is sectoral. It's compartmentalized in a way. It's efficient, but on the other hand, it doesn't really manage well the interconnections between these businesses and the interconnection between the businesses and environment and climate concerns. And internationally, it's even worse, of course, since outside of the jurisdictions, you have treaties like Rector mentioned, for example, related to the Arctic, to Spitsbergen, etc. But and you have overall the treaties on ocean law, but that's not enough at all for example exploration of fish stocks, etc. So there are lacks of management systems and the ways of thinking about management systems nationally as well as internationally. Someone has said that Norway has the, I think it's the government probably, Norway has the best ocean management of all countries. That only says something about how it is in the other countries, basically. Because it's sectoral. I'm not saying that all these sectors are badly managed, but they need more thinking. Because we have fisheries separately handled, oil and gas separately, ocean fish farming, ocean wind power, seabed minerals. They have separate laws, seen from a lawyer's point of view, but the reason why they have separate laws, of course, is that they also have separate agencies. Oil and gas covers also carbon storage, for example. So all these new developments need to be thought out and organized within an overarching management or governance. I don't like the word governance, by the way, because governance basically means that it's not real management, it's just something happening. Anyway, then we have what's happening now. How would this fit in? And that relates to something that the Rector just said. The Støre government has revised the allocation of competencies related to oceans. So it's not only that the Minister of Fisheries is now Minister of Fisheries and Ocean Policy, which is his formal title in English. Ocean Policy. They've also, I just checked the ministry homepage, the Ministry of Trade, Industry and Fisheries is responsible for the trade, industry and ocean policy. That's explicitly said on the front page of the ministry. We don't know what that means, of course, and especially ocean policy. How does that relate to the Ministry of Oil and Energy, for example, which hasn't lost any competences? So there would be strong, not fights necessarily, but at least strong tautrekking between these ministries, of course, in the coming years. But what is important is that this is really a window for forming a research policy or a research strategy to assist the government in doing this. They ask for it here, of course. Ocean policy, yes, we can fill that. And then, as also Rector mentioned, Støre is now appointed co-chair of the high-level panel for a sustainable ocean economy. I think maybe that's partly because it was invented by Norway anyway, the panel. But anyway, that's also important. It also demonstrates that Støre, the new prime minister, is willing to take on that job. So what should be done? This could be done bottom up or top down, since we have both top and bottom here. So we could just meet in a couple of minutes. But I think that the different relevant units at university and beyond should come together, either to prepare for the revised government research plan, if there is such a plan coming, or to initiate interdisciplinary ocean research projects, no matter what happens really on the research planning from the government side. These issues are too important anyway. So you should just see what could be developed also with the resources that we already have. And then maybe in parallel, maybe beforehand, maybe afterwards, the university leaders should consider developing a formal strategy. And I suggest based on the position paper, but you don't need to use sort of our or the university's position paper to do that. But I think the beauty of that paper is really that's already based on input from all, or at least very many of the different relevant environments which really do ocean research. Then, coming back to the Arctic, I think that Arctic research should, because of Norway's position, of course, related to the Arctic, should just be developed, or could be developed within this as a special sector, a special type of projects, or special element of the strategy. Thank you.
Thank you very much, Ola. Is there any questions or comments to Ola's presentation here?
Is anyone against it?
No? No. Okay.
Perfect.
Perfect. Yes, it is. Okay. So then I can start. Now we have been looking a bit into the future, what we should do in the future. So now we'll take a step back. And I would like to introduce Professor Joe Lacasce from the Department of Geoscience. He is a physical oceanographer with focus on the dynamic of large-scale currents and waves, which Ola summarized all oceanography to be. So besides this, Joe also has a large interest in the history of Scandinavian oceanography and metrology. So he will share a bit about this with us now.
Okay. Thank you. Let's see, how do we get this to work? Full screen. There, okay. Yeah, so thank you. So we heard mention of physical oceanography. So I'm going to give a little background about what physical oceanography actually is and why actually it's so special here in Scandinavia, because it was pretty much invented here. So physical oceanography, I mean, it's really, so I'm actually a physicist. That's where what I grew up studying was physics. But I couldn't, when I was studying physics, I couldn't actually find any particular areas of physics that I was really interested in doing. And then I found out it's actually possible to do physics of the ocean, you know, and that for me was absolutely fascinating. So physical oceanography is, I mean, in oceanography itself, there's chemical oceanography for the chemists, you know, there's physical oceanography for the physicists, we have geological oceanography, we have and marine biology, of course, too. But physical oceanography is really the dynamics, how the system works. And there are two types of oceanography that are you can mention here. There's descriptive oceanography and dynamics. So and I'll explain where those two things come in here. Now, a long time ago, oceanography was primarily descriptive because people were sailing all over the place back in prior to the 1600s. Of course, this was the great age of exploration, and when people were sailing around, and so it was very important to know actually what the ocean was doing. You know, if you were to sail around the tip of South Africa or South America, you really want to know what the oceanography is like there, in addition to the weather, because it'll make your life a lot easier when you're sailing there. So people started making maps to describe the circulation very early on. So Benjamin Franklin, one of my compatriots from the United States, actually drew a map of the Gulf Stream back in 1775, where he described this river of fast-flowing water just off the east coast of the United States over here. Oh, I got a pointer. Over here, okay? It was much easier to sail to Europe if you were in the Gulf Stream than if you weren't in the Gulf Stream. And vice versa, if you were sailing back, you did not want to sail against that current because it would take a lot longer to do it. Here's another example of an early map of what the oceans looked like back in 1845. Okay. Just to mention a couple of people, James Rennell and Alexander von Humboldt. Rennell was a British researcher who was surveying for the Royal Navy and wrote a book. This is an early book, 1832, on the currents of the Atlantic Ocean. So again, describing what the currents look like. Von Humboldt was a famous German researcher. It was one of these polymaths, worked across different fields, traveled extensively in the Americas. He's actually, interesting, one of the first people to describe human-induced climate change. So back in the 1850s, 1860s, or even earlier, I think, maybe earlier than that. But as far as oceanography goes, he also did an early map of the Gulf Stream, wrote about the equatorial currents, and then was thinking about why, if you were, for instance, at the equator, the surface waters are warm, the waters that are down deep are a lot colder, and he thought, well, probably that water is coming from the poles. So it was the first time people were still starting to think about, about how large-scale circulation was happening. Okay, well, in the late 1800s, there was basically a revolution going on in physics. This was a big deal. So Maxwell, for example, developed Maxwell's equations, which describe electromagnetism, and wrote this important book on the theory of electromagnetic fields. And so this had a really big impact in physics. At the same time, in fluid mechanics, there was a famous text that was written in 1879 by Horace Lamb about putting fluid mechanics on a mathematical basis, okay? And back in this time, though, meteorology and oceanography were really seen as sort of hobby sciences. This is what you do if you were on a ship and you were sailing, you didn't have anything else better to do, right? You just describe what was happening in the ocean. No one really cared, okay? So it was like moth collecting, as some physicists would say. Okay, but then in Scandinavia, we started to have this revolution because people started to apply these ideas about physics to describing the ocean. So one of the first people was Henrik Mohn, who studied, and I always find it very interesting to see where they come from. He studied theology, at the University of Oslo. I have students who pray during my exams, and they were not the first. I mean, so Mohn started prayer before he got into physics and astronomy, and then moved to meteorology. But he wrote a text about storms in Christiania back in 1863. He was a founder of the Norwegian Meteorological Institute and the first director, and he published a widely read text in meteorology. So anyway, one of his ideas, I'll just mention a couple of these, is the idea of something that he called the baric wind. And that was the idea that the winds are related to pressure. So if you ever look at pressure maps, if you look at NRK, you look at the weather forecast at night, they'll show pressure maps. You'll see low pressures and you'll see this. And the idea that the winds are actually linked to those pressure distributions. Okay, it's something that we now today call geostrophic balance, but it's a fundamental balance that exists in large-scale circulation. And this goes back to Henrik Mohn. He also applied ideas back in those days. I mean, they didn't see the difference between working in meteorology and working in oceanography, which is sensible because they're very, very similar systems. So he applied some similar ideas in the ocean, and in particular described some of the circulation that was happening in the Nordic seas, and he led a big expedition in 1874, also in these northern regions. The important thing that comes in later is that he talked about, he thought that what was happening in the Arctic Ocean is that there was what we call the transpolar drift. So that there was a drift going across the Arctic Ocean of ice and so forth. And that is what prompted Fridtjof Nansen's trip to the Arctic Ocean in the Fram, so later on. Okay, then comes this person. So this is Vilhelm Bjerknes. So you're sitting in Bjerknes' house right now. And Bjerknes, you can't overstress how important he was for the development of this whole field. Enormously important. So he was an assistant to his father early on, and then he studied with Henrik Hertz studied electromagnetism in Germany. So went through physics. Then he came back and was a professor of mechanics at the University of Stockholm, and then subsequently was here and also at Leipzig, and before starting the Geophysical Institute in Bergen. He did all sorts of things. So one of which he was the first to write down what we now call the primitive equations. These are the equations that we solve when we're doing weather forecasting. So the Meteorological Institute is doing weather forecasting. They use the primitive equations. He was the first one to write that down. There's something called Bjerknes forces. If you study acoustics, in bubbles in particular, very interesting for the Navy. You know, it sounds silly, you know, it seems like only people that are interested in beer would be interested in bubbles, but it's actually important for the Navy. And he developed something called Bjerknes circulation theorem. I'll show you what that is. He even has a crater on Mars named after him. So if you go to Mars, like Elon Musk recommends we should all do, then you will see eventually Bjerknes's crater. So he's even celebrated there. Circulation theorem, if you like math, and this is what it looks like. I mean, I know there's one person in the audience anyway who likes math, so most people don't. But anyway, what it has to do is what kind of flow you get around a closed curve. So it sounds very mathematical, but it's extremely useful concept. For example, you can apply it to something like sea breeze. You know, if you're on land in the summer and you have colder ocean, then you develop what's known sea breeze. It's great if you like to sail, and you can understand that with Bjerknes's circulation theorem. And you can apply it to a number of different things, cyclogenesis, coastal upwelling, a number of ideas like that. Okay. Taking my quick tour here. This is Bjørn Helen Hansen, so this is another one. Studied medicine at the University of Oslo, okay, was doing medicine. But thankfully for oceanography, not so good for him. He lost several fingers when he was on doing a field work in Finnmark, and so he couldn't become a surgeon, right? You can't operate if you don't have all your fingers. So instead, he studied marine science in Copenhagen, and he worked with Fridtjof Nansen, who we'll come to, and the North Seas, and he was an assistant to Bjerknes. So like many people, he had a connection to Bjerknes. So he applied the circulation theorem, Bjerknes's theorem, to oceanography, developed measurements for marine optics, and was a later director of the Geophysical Institute after Bjerknes. This is a kind of a cool thing. So my friend Cecilia Moritzen drew a circulation scheme in the Nordic Seas. This was her thesis work back in 1996. Right, and so you have a current that's flowing north along here, splitting, going into Spitsbergen, and circulating the Arctic Ocean, then coming back out again. And if you compare her diagram, and she'll be the first to admit this, that it really was just a redrawing of what Helen Hansen and Nansen drew back in 1909. So their description of the circulation in the Nordic Seas and up into the Arctic was very remarkably accurate. Okay, this was forgotten in years in between, and then Cecilia resurrected it in 1996. Okay, and here's Fridtjof Nansen. Okay, everybody knows about Nansen if you're in Norway. He's quite an amazing character, though. Studied zoology at the University of Oslo. There aren't many of us, oceanographers who broke the world 1 mile cross-country ski record. Brit is probably one of them, but there aren't many others who've done this. He was 18 when he did that. He skied across Greenland, and he was nearly the first to reach the North Pole. Okay, so he almost did that. Mapped out the currents, invented the Nansen bottle in oceanography, and was awarded the Nobel Peace Prize. It's just incredible, right? What this guy is amazing. But anyway, we're talking about oceanography. There's a couple of things that he did. So he was motivated by Henrik Mohn's idea that there was this transpolar drift in the Arctic Ocean. So he, of course, as you would, he designed a ship that could freeze into the ice. And then the idea was he was going to drift across the Arctic and then be the first to go to the North Pole. While he didn't get there, got close, but he made a couple of important observations which then got integrated into dynamical oceanography. One of them is the concept of dead water. Okay, so sometimes when you're sailing along in a ship, and there's no waves at all, no apparent waves at all, but the ship is really struggling to move. Okay, usually you should be going faster than you expect, and you're not moving very fast. So he described this. He said the Fram was capable of going 6 to 7 knots, but it was in the dead water. She wasn't even able to do 1.5 knots. So he described this, thought that was interesting, and wrote it down. He really was a naturalist and an observationalist. Here's another one. He noticed that when the wind was blowing this way, the ice did not go that way. The ice drifted off to the right. So, and he said typically 20, 40 degrees to the right of the ice. Okay, so and he had some ideas about why it was doing this, but he went back and he described this to Vilhelm Bjerknes, okay, at the University of Bergen. He said, boy, these weird things. Well, Bjerknes said, I got a good student, okay? We've talked a lot about Norwegians, but there are some Swedes here too. And there is this guy, Ekman, was a student of Bjerknes who was working with him. Ekman studied physics at Uppsala University, But he heard one lecture by Vilhelm Bjerknes, and then he switched over to oceanography. He was so inspired by Bjerknes, he switched. And then he later went to work with him too. He also was a bass singer, by the way, and an amateur composer, fascinating guy. He solved both of these problems. So he worked he wrote a paper in 1904 on dead water. And this is what Bjerknes thought was going on, that when you have a ship on the top, you also have waves under the surface. We now call them internal waves, okay? But they weren't known at that point. But the ship can excite these internal waves under certain conditions. And of course, it takes energy to excite those waves. And that's why the ship was struggling, because it was making these huge waves. I mean, the amplitude can be 100 meters high under the surface of the ocean. So they were actually going back to Ben Franklin again, one of my heroes. He described it in 1762, but not in this terms. It was more the idea that if you have two liquids, you get waves on the interface between them. The other one is this business about why the ice was going off to the right. So he developed a very simple model, which I use, in my first semester master's course on dynamical oceanography, which showed exactly this. And the wind is blowing this way. Because the Earth is rotating, the ice drifts off to the right. And he gives a prediction about how it should go off to the right. Now we have things in oceanography known as the Ekman spiral, the Ekman transport. We have Ekman flux, everything else. I always say to the students, I said, it's a great example. If you want to be famous and you want your name in the field, make sure you have a good advisor, okay? Because, Ekman had Bjerknes, and that opened up all these doors. Okay, so it's no exaggeration to say by 1910, Scandinavia completely dominated this field. Not just dynamical oceanography, but dynamical meteorology as well. And people came from all over the world to do postdocs here, for example, because this is what they wanted to do, it's to work with these people. Thereafter, the research began to shift abroad, particularly to the United States. But Scandinavians continued to contribute. So this is Carl Gustav Rossby. It's another person in our field that his name is all over the place. He was studied mathematical physics in Stockholm. Again, converted to meteorology after meeting Bjerknes. So Bjerknes again convinced him to do this. He became a professor at MIT, my alma mater, and then was at the Woods Hole Oceanographic Institution, where I also worked, and then divided his time between the US and Sweden. Also championed atmospheric chemistry, studied how CO2 could warm the atmosphere. So like von Humboldt, coming back to this idea about global warming. And he also has a crater on Mars named after him, too. So if you look for that if you're up there next time. Rossby waves are a fundamental dynamic in meteorology and oceanography. We use them all the time to think about how the ocean reacts to, for instance, climatic change, and also how the weather behaves. That's these wavy patterns. This is a jet stream, and it has this sort of wavy pattern. We think of those in terms of what we call Rossby waves. And this was discovered, the concept, by Rossby in 1939. This is a satellite picture of the Pacific Ocean, and these blobs are Rossby waves propagating across the ocean. Very large scale. Here's another one. I don't know how I'm doing for time here, but okay. Harald Sverdrup is another one. I always think, so I'm an American, and then I moved to Norway, to do oceanography. Sverdrup did the opposite. He studied rail fog at UIO. He was a student at Bjerknes, surprise, surprise, and scientific director of a number of things. Became the director of Scripps Institution in Oceanography. So he moved to San Diego in California, and then basically started their whole program in oceanography and everything else, and was later a director of the Norwegian Polar Institute. You see this too. A lot of the Scandinavians will keep coming back, okay? But very, very important figure at Scripps. He was the advisor of Walter Munk, who became one of the great early theoreticians in oceanography. Sverdrup, just to mention it, because I think it's such a great idea, he has a very simple, as far as equations go, this is about as simple as they get. And what this does is you can use this to describe large-scale circulation, for instance, in the Pacific Ocean. So you have these gyres like this. This is the Kuroshio current that's over here, and this is the large-scale circulation. You have something similar in the Arctic Ocean as well. And this is what we now call the Sverdrup transport, or the Sverdrup stream function. And these are named after Sverdrup as well. So this was something else. And it's remarkably good. It's a very, very simple relationship like this, but it basically says if you know the winds, then you know what these circulation patterns look like. He also wrote the first important textbook on ocean physics, chemistry, and biology. So this is Sverdrup, Johnson, and Fleming, and for decades this was the standard text in the field. A couple other influential Scandinavians. Arndt Eliassen was actually in our department. He actually had my position, so I am holding the Eliassen chair. One of my colleagues asked me this and was told, "Joe, do you have Eliassen's chair?" And I said, "Yeah, I think I do." Arndt Eliassen, professor of dynamical meteorology at UIO, he developed something that we now call the quasi-geostrophic system. It's a set of equations that we use for studying the ocean and the atmosphere. Did a number of other things. And then this is Ragnar Fjørtoft. Interesting, Arndt Eliassen's son was Anton Eliassen, who was the previous director of the Meteorological Institute. And Anton told me that Arndt, so these two were colleagues. This guy Ragnar was a brilliant guy, but gave the worst lectures you could ever imagine. And so people would ask questions, and then he would answer, and nobody understand what he said. And then Arndt would then translate for him. And so he said, well, what Ragnar means is this, blah, blah, blah. And so Arndt once said, well, Anton told me that Arndt said, I feel like my job in life is to translate, so for Ragnar, so that people understand what he's talking about. Anyway, Ragnar was the director of the Norwegian Meteorological Institute also, and developed some interesting ideas about turbulence and so forth. Fascinating stuff. Okay, so just briefly, Scandinavian legacy for the language. We have the Bjerknes circulation theorem still. Ekman spiral, Ekman layers, Ekman transport, Sverdrup balance, Sverdrup transport, Rossby waves, Eliassen palm fluxes, and the Fjørtoft stability criteria. All of these are Norwegian or Swedish contributions to the field. So it really, I feel like we really ought to feel like this is, physical oceanography and dynamical meteorology are, we invented it basically. So there ought to be a lot of pride about that. And how did it flourish here? Just briefly, a lot of it was, it's an interesting sociological question too, because why did it develop here? Well, a lot of it had to do with this guy, with Bjerknes, because Bjerknes was such an inspiring figure. He had such brilliant ideas that people came, they heard a lecture of his and then changed fields. They went from medicine over to meteorology, or they went from mathematics or even carpentry over, and just they heard a lecture of his and did this. And so that includes Helen Hansen and Ekman and Mohn. Sandström, I didn't even mention him, Sverdrup, Rossby, and Nansen. All of them were affected by that. So that often happens. You have some person in the middle who is like and sets off this chain reaction in the field. Very important. Oh yeah, and this is the last slide. So this was a colleague of ours also in the field, just to show this is Ekman spiral, has also made it into poetry. He wrote a song about the Ekman spiral. Fridtjof Nansen wanted to go home, and the Fram, he was sailing, blah, 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 and it's about, so experiencing the Ekman spiral. Okay, so that's all, yeah.
Tour through the history of
Yeah.
very, very good. Thank you.
Okay, welcome back to section 2 of the Arctic Day 2021. There are 4 speakers in this section, and the first one is actually my colleague, Professor Geir Ulfstein, who will talk about who may decide what, Arctic jurisdictions, competing claims, and the status of the maritime areas around Svalbard. And Geir, he's a leading professor of international law, including environmental law, but his doctoral dissertation was directly on the Svalbard Treaty from terra nullius to Norwegian sovereignty. That was published in 1995, and since that he has, at least from time to time, followed that issue quite closely, also discussing in the newspapers and other media. So he's not only sort of scientific author, but also a man meeting the public on these issues. Geir is also the co-author of the leading Norwegian textbook on international law, so all law students have to read his book. Formerly, he's a leader of PluriCourts, which is a Norwegian Center of Excellence. And please, Geir.
Thank you very much, Oda, and thanks for the invitation. So now I will speak about international law. There will be 2 parts. One is the more general international law, law of the sea issues, and the second part is particularly on the Svalbard Treaty, and particularly its application to the maritime areas around Svalbard. So here is a map of the Arctic Ocean. When I give lectures about this, I compare with Antarctica. Antarctica has been described as a land surrounded by sea, whereas the Arctic is sea surrounded by land. And my question is then, what governs this area? Is it anarchy or is it a legal order? My response to that is that there is a legal order, and the legal order is found in the Law of the Sea Convention from 1982, which has been characterized as the constitution of the ocean, governs the establishment of economic zones, continental shelf, deep sea regime, etc. So there is a law for the oceans, also governing the Arctic. And if I should give you a crash course in law of the sea, we have different zones outside different countries, coastal countries, which starts with the internal waters, continues with the territorial sea, which may be extended to 12 nautical miles. But our concern is mostly the exclusive economic zone, 200 nautical miles, and also the continental shelf, which may even go beyond 200 nautical miles. And the area outside 200 miles is called the high seas. And the general system is that the coastal state has more rights the closer you come to the shores. So in the territorial sea, the coastal state has full control. When we go further out to the exclusive economic zone, the state has sovereign rights, not sovereignty, sovereign rights for certain purposes, particularly economic exploitation, management of fish resources, etc. And more or less the same applies to the continental shelf. So how does this play out in the Arctic? If we go to this map, it gives an overview of the different claims of continental shelves in the Arctic. And what you will see there is that these claims overlap between Russia and Denmark, Canada and the United States, etc. And I'm not sure what you have heard earlier, but there is a United Nations Continental Shelf Commission which deals with the extension of the continental shelves and can give recommendations about the outer limit of the continental shelf. So we have a system in place for determining the outer limit of the continental shelves. The problem is more the delimitation between different countries, neighboring countries, adjacent countries. But there we also have extensive case law from international courts about the delimitation between different countries. So generally, I would say that we have a regime that works also here. One difficulty is that the USA is not part of the Law of the Sea Convention, so the UN Continental Shelf Commission cannot deal with the claims by the US. And here is then a map of the continental shelves in our area. What is interesting here is also that there are two areas that are beyond the 200-mile zone. That is the loophole in the Barents Sea and what is called here the banana hole in the Norwegian Sea. So in the Barents Sea, this loophole is governed when it comes to the continental shelf by Norway and Russia, because there is they both have shelves in this area, but it is beyond the 200-mile zone. And also when we look at the map of 200-mile zones, we see the Norwegian 200-mile exclusive economic zone. There is a fisheries zone around Jan Mayen, not an exclusive economic zone, and a fishery protection zone around Svalbard, which I will discuss further. So if we then focus on Svalbard and start from the land area and the Svalbard Treaty. I will not go into any detail, but the treaty was adopted as a result of the peace negotiations after the First World War, the Versailles negotiations. There was a special Spitsbergen Commission that was established under the peace negotiations. Before the Svalbard Treaty, Svalbard was no man's land, so-called terra nullius, but the treaty established that Norway should have sovereignty, but Norway could not discriminate among states when it comes to the economic use of this area. So in a sense, parts of the former regime continued the open access regime earlier. And then there are restrictions on taxation. So all the tax that is collected on Svalbard shall be used on Svalbard. That's not a problem today because Norway is subsidizing all activities on Svalbard. But it may be an issue if there is oil exploitation on the shelf around Svalbard. And then there is a provision on peaceful utilization. But I will say something also about research on Svalbard, but then I will move out to the sea. So the question is then how to interpret a 101-year-old treaty, which was, of course, negotiated on the basis of the activities in 1920 and not in 2021. So how to interpret a treaty under the current conditions. One issue has been the research activities on Svalbard, and Olav Schram Stokke is now editing an issue of the Polar Journal, where there is an article about the Svalbard Treaty and research, and also made a contribution there. The question is, or one main question is to what extent the non-discrimination principle also applies to research. Can Norway favor Norwegian research at the expense of foreign research? And there has been a claim that some countries, I won't mention China, is using research for non-research purposes, for promoting national interest. So it might be of interest. But if we look at the provision concerning research, it's not very clear. It says that there shall be new conventions concerning research, and no such conventions have been negotiated and adopted. So my conclusion would be that Norwegian sovereignty prevails. Norway can discriminate if Norway wants to, but so far Norway has not done so. if we go then to the maritime areas around Svalbard, there are 3 questions. One is to what extent the Svalbard Treaty applies beyond the territorial sea. Does the treaty apply in the exclusive economic zone and on the continental shelf? If so, then the provision on non-discrimination would apply. And that raises question, what is non-discrimination? And the third question, particularly concerning the continental shelf, is to what extent the taxation regime applies to any oil activity or other activities on the continental shelf. Again, the provisions is not very clear. The wording is clear. It says that the treaty applies in the territorial zone. So that's clear. But it doesn't say anything about the areas beyond the territorial zone. And Norway claims that the treaty does not apply. Many other states say the opposite, so there we have a conflict. And that is one of the reasons why Norway established a fisheries protection zone rather than an exclusive economic zone, and said that we will, for the time being, not discriminate foreign fishing, not because we don't have a right to do so, but because there is no need, and because we do not want to have any conflicts. So this is a regime which has worked well so far, but then the UK decides to withdraw from the EU and agrees with the EU about allocation of quotas around Svalbard. Norway says that, well, it's not up to you to decide on quotas around Svalbard, and that's for Norway to decide. And Norway and the EU disagrees about the allocation of quotas, of EU quotas, in the 200-mile zone around Svalbard. Now it seems in the next few weeks that the EU vessels have fished their quotas, and then there is a question for Norway to arrest all the EU vessels and have a full diplomatic crisis. So that will be interesting. The other issue is the snow crab conflict. Suddenly there is a new species in this area. Norway says that the allocation of quotas has been based on traditional fishing. There is no traditional fishing of snow crabs. Therefore, we will not give any other country quotas on snow crabs. We will keep it for ourselves. Which other countries, including EU countries, protest? So we have interesting times. And then we have oil activities moving further and further north. Question about to what extent oil drilling on the continental shelf around Svalbard is subject to non-discrimination and to the taxation regime. Of course, there is a debate about how far north one should drill for oil, which has also a climate aspect, not only a Svalbard Treaty aspect. But we have the Svalbard issues also. We have shipping in the area, and increasingly so, including the possibilities of the Northern Sea route and possible pollution from shipping in the area, and the question about who decides, who enforces regulations. And finally, we have a new issue about the exploitation of mineral resources in the Barents Sea and in the Norwegian Sea, and what kind of legal regime applies to these areas, including to what extent the Svalbard regime applies to the continental shelf around Svalbard. So there are many interesting legal issues here. that have not been resolved and which will continue to be interesting for lawyers. Thank you.
Thank you very much, Geir. Are there any questions? We have a couple of minutes for questions to clarify the status of the different issues. But what are your predictions, actually, what will happen, for example, with the mineral seabed minerals developments?
I've not followed that closely, so now there is an impact analysis of the possible consequences of mineral exploitation, but then there is an issue about the commercial interest, but also to what extent the Svalbard Treaty could be applicable depending on which area which is most promising for extraction.
But then if there is a conflict coming up, who will then decide that? Would it go to The Hague?
It could go to The Hague, to the World Court in The Hague. There are several countries that have threatened to bring the case before the World Court, but so far none have done so, and there may be several reasons for that. The outcome is not sure. Maybe they would lose, maybe Norway would lose, and of course that is only for the states that have accepted the competence, the jurisdiction of this court, for example, the UK or Spain or some other countries.
Norway has accepted it.
Norway has accepted it. Yeah.
So we can be challenged there,
yes,
as long as the others decide to do that.
Yeah, but not by the EU as such, because it's only open for states, not for international organizations.
So the EU member states, or one of them, like Poland or whoever, could challenge Norway in the court.
Yeah.
And if then Norway loses, what happens then?
Then I think that Norway would accept it. It happened in 1933 concerning East Greenland, which Norway accepted. We had the Jan Mayen case on delimitation between Greenland and Jan Mayen, which was accepted. Well, Norway said that we had offered Denmark more than they got in the judgment, so Norway was happy. But now we have an interesting case with the UK, the Chagos Islands case about the Chagos Islands in the Indian Ocean, where the court said that this belongs to Mauritania because of the decolonization, and the UK says we will not accept this. So we will not obey the World Court.
Which is very exciting for an international lawyer.
Absolutely.
Okay, thank you very much. Our next speaker is also a lawyer. It's Froukje Maria Plato. She's working with the Scandinavian Institute of Maritime Law, my institute, and then also with Norwegian Institute for Water Research, and she is especially interested in sustainable governance of transboundary ecosystems, which is extremely complicated, of course, and interesting legal issues related to different countries' jurisdictions. So, Froukje, please.
Yes, thank you so much for that nice introduction, and thank you for organizing this day and for having me on the program. A lot of interesting presentations so far, and I really enjoyed it, listening to it. So I hope you will enjoy my presentation as well. My name is Froukje Maria Platjouw. I work as a researcher at the Norwegian Institute for Water Research on a lot of different types of research projects, mainly related to marine and coastal governance. And then in addition, I do this postdoc project at the Maritime Law Institute on the issue of ecosystem-based governance in the Arctic. The postdoc project is facilitated by the Maritime Institute, as well as by UEO Arctic. because I do it side by side to the NIVA position, it is organized as a 4-year project. So it started in 2017, and it is still ongoing. And it's actually the first time for me presenting something at the Arctic Day. I thought maybe I could use some minutes to just show some of the outputs and the results and the activities that we have done during the project. Conceptually, the postdoc project is some kind of continuation of my PhD research on environmental law and the ecosystem approach. And this is, the PhD research is not really related to the Arctic, but it's very much focusing on the question of how we could overcome certain characteristics in environmental law, such as fragmentation, which is a problem, how we could overcome that and work towards more like ecosystem-based governance approaches and legal coherence between different fragments of law, institutions, policy sectors, etc., towards more coherent and harmonized governance. So I will discuss this a little bit later, but one thing that fascinated me during the PhD research was how adaptive governance, which is necessary for marine ecosystem governance, how it could be facilitated by law. And when the postdoc project started, one of the first things we did was to organize an international workshop on this particular issue. So we asked how to reconcile the rule of law, which requires legal certainty, predictability, transparency, with at the same time this need for adaptive governance of marine ecosystems. And then we focused in particular on the Arctic, but we also had presentations looking at other areas, other marine areas. So we had this workshop in 2018, which then we followed up by developing this special issue, which was published in Marine Policy the year after, where we presented an introductory chapter on the concept and the challenging balance between both ensuring adaptive governance, but also in abiding to the rule of law. I wrote a chapter on the dimensions of transboundary legal coherence, which is the one that I will present today. We had some chapters on fisheries, and we had some chapters on aquaculture. So this was in 2019, and then at the same time, Alla Posnakova, the professor at the institute as well, and we were thinking about organizing a broader conference on this issue of how law could actually foster and strengthen the protection of the oceans. So not only related to the Arctic, but more broader, related to all kinds of marine areas around the world. So we organized this international conference in 2019, which is then about the rule of law for oceans, and it questions whether law is actually fit for purpose to protect our oceans against increasing pressures and increasing demands. It had great interest from many participants, where I think we welcomed about 100 participants from different areas of the world. And then after the conference, we worked further with a group of participants on the book, which will be published next year by Cambridge. And it contains about 24 chapters divided over different themes. And the nice thing is that the entire book will be available open access, thanks to support and contribution from the Maritime Institute and NIVA. So this is very exciting for us to work with. Now the topic that I will discuss, oh sorry, I forgot one slide. This is just an overview of other projects that have been ongoing during this process, but mainly from my other position at NIVA. So this has been projects that I've been involved in and worked with. The first two are still ongoing, but the rest is all concluded and ended projects. So some of them are NFR projects, others are from center projects, and some of them are tenders. So I'm not going to this, but some of them are quite relevant for the Arctic as well. So if you want to discuss or if you have any questions, we can, you know where to find me. The topic for today that I would like to discuss is then the potential of legal coherence to facilitate transboundary ecosystem-based governance. And this research is very close to my heart because it's very close to, to the PhD research that I did at the Faculty of Law. So it questions actually how legal design could foster ecosystem-based governance. And ecosystem-based governance aims at a better protection of our marine ecosystems and our oceans. But what's actually the role of law? How could law as an instrument contribute to making it easier to implement, making it easier to operationalize in practice? And this interest, it started really during this PhD research that I started in 2008 on the topic of consistency in environmental law. And environmental law, as also Ole indicated and the Rector, it is a very fragmented field of law. You have both horizontal fragmentation between sectors, you have vertical fragmentation between different layers of governance, which all kind of stand in the way of making such a kind of ecosystem-based governance approach, which is much more holistic in a sense. So when it comes to ecosystem-based governance, we see that the legal and also the institutional fragmentation really is an obstacle. It really stands in the way of operationalizing ecosystem-based governance. And we need to think about ways on how to, because we have this fragmentation, we cannot undo it, but we need to find ways to make the different segments more coherent. They need to be more harmonized in order to make such an ecosystem-based governance approach realizable. So what is ecosystem-based governance? And it really is it really is an approach that's difficult to describe in one sentence. There are many different definitions that exist from different legal and policy instruments, from the Convention on Biological Diversity, the Malawi Principles, different conventions, EU directives, policy instruments. The definition is the concept itself is defined in very different places, and you can have a long list of definitions that refer in one way or another to ecosystem-based governance. But to summarize it anyway, we can describe it as a governance approach that requires multi-level, polycentric, and participatory governance structures to ensure the maintenance of ecosystem integrity and its functioning, while also sustainably using its services and enjoying its benefits. Now, this is a very long definition, and it really doesn't tell us much yet. It's also important to remember that the concept itself is very multifaceted. There is no definition that actually can describe what it exactly entails. So it's kind of adjustable to the particular context. It's very context related. So a particular ecosystem approach that's appropriate for a particular ecosystem might be different than to the other ecosystem under different circumstances. It's also important that there are different tools and mechanisms that might be appropriate. And often it's a mixture, it's a combination of different tools and mechanisms that's appropriate for a particular situation. So these are kind of examples of tools that are applied as tools that should foster ecosystem-based governance. You can think about ecosystem service valuation, the use of environmental principles such as cumulative effects or the precautionary principle, marine spatial planning, big data handling mechanisms, environmental quality indicators, certification as a tool, marine protected areas, strategic impact assessments or environmental impact assessments, integrated management plans, payment for ecosystem service. It's a long list. Monitoring, of course, is important. And then legal design, that's kind of my main interest for fostering ecosystem-based governance. So a legal design as a tool to make it easier to operationalize. So I will talk mainly about this tool as legal design, but before we do that, I think we need to simplify a little bit the concept of ecosystem-based governance. we need to detangle it a little bit to make it easier to clarify what kind of legal coherence would actually facilitate which aspects of ecosystem-based governance. So I like to think about ecosystem-based governance as requiring three types of three dimensions of governance. And the first one is holistic. Holistic governance requires that we manage beyond administrative and jurisdictional boundaries. As you know, marine ecosystems, they're often shared by different states, different regions. They're divided into different maritime zones with different rights and duties. But we have to govern these ecosystems based on their geographical and ecological premises. That's the idea of holistic governance. Then integrated governance is important because ecosystem-based governance is looking for an appropriate balance between, but also the integration of both conservation and sustainable use. So it requires a weighing and balancing of diverging interests, diverging priorities and values that needs to be carried out at different levels of governance, but also by a range of different decision-making and policy-making authorities. So, and then adaptive governance is also crucial because ecosystems, they're complex, they're dynamic, and we will never ever have complete knowledge on their functioning, and we will never understand completely how they function. So we need to be adaptive in order to be able to respond to these kind of uncertainties. And we need to adapt like learning by doing. We need to apply research feedback in governance systems. Now the idea is that legal coherence could actually foster each of these types of governance. Holistic, integrative and adaptive governance could be strengthened through legal coherence. Legal philosophers have said that law is coherent when it hangs or fits together, when its parts are mutually supportive, and when the different fragments flow from or express a single unified viewpoint. Legal coherence in environmental law is not studied so much, actually, as opposed to policy coherence, which is generally described as an attribute of policy that systematically reduces conflicts and promotes synergies between different policy areas to achieve outcomes associated with jointly agreed policy objectives. So if you, for instance, think about Sustainable Development Goal 14, you could say that, okay, in order to conserve and sustainably use the oceans, the different policies together should contribute to that overarching goal and objectives. And we should not have any internal conflicts that slow down progress towards that overall objective. In general, legal coherence is also important as a rule of law value, as it contributes to predictability, legal certainty, and also transparency. And it has in addition been acknowledged as important for sustainable development. So Sustainable Development Goal 17 explicitly refers to this policy coherence as important, as something to aim for. But in the context of ecosystem-based governance, it's particularly interesting because it has great potential to facilitate ecosystem-based governance. And certain forms of legal coherence could contribute to the implementation of EBG, and I will explain what kind of coherence is necessary for each of these components. So, in terms of holistic ecosystem-based governance, as I said, holistic ecosystem-based governance requires managing beyond administrative and jurisdictional boundaries. And fragmented structures of law and governance, they do not fit well with this transboundary nature of marine ecosystems. Ecosystems need to be regulated as a whole, rather than splitting up the ecosystem into different maritime zones and different jurisdictional zones. But this is not an easy task because regulation and enforcement is often very effective if it's specialized, if it's very tailor-made for the particular zones, for the particular problems, for the particular pressures, and the particular areas. But still, the need for an ecosystem approach requires kind of horizontal regulation that cuts across political interest, these legal zones, different interests, different resources, etc. It requires for holistic approaches towards the marine ecosystem. So fostering holistic ecosystem-based governance requires legal coherence among objectives, principles, rules, terminology, definitions used across legal acts, across legal frameworks, and even across jurisdictions. For example, legal frameworks regulating aquaculture activities in different parts of a shared marine region should employ similar terminology, similar interpretations of concepts that they use in order to facilitate cross-boundary coordination and cooperation. Integrated governance. Legal coherence is also important for integrative governance. Ecosystem-based governance aims at a fair balancing of both sustainable use and the maintenance of ecosystem integrity in order to ensure the long-term resilience and productivity. But to attain both aims, integrative governance is necessary and requires cross-sector coordination and also public participation. What we see in environmental law and governance is that due to the degree of fragmentation, decision-making authorities use different approaches, different mechanisms, different traditions with regard to the weighing and balancing of diverging values, diverging interests when they make decisions. So this renders cross-sectoral coordination very difficult in practice. And as a result, a good balancing or a good integration between sustainable use and conservation is not really ensured. So in order to ensure this, in order to ensure that these ecosystem values are not integrated and considered partially and fragmented, decision-making principles and methodologies need to be coherent across sectors and across jurisdictions. We need to apply a coherent set of decision-making principles, mechanisms, methodologies for the weighing and balancing of diverging values, which are often conflicting as well. So we need a more systematic and coherent manner to do this. And finally, legal coherence could also foster adaptive governance. The level of scientific uncertainty related to most marine ecosystems and the unpredictability, it necessitates cautiousness and adaptivity in decision-making procedures. Adaptive governance requires that we continually monitor and review past decisions, past plans, programs, etc., and adjust goals and actions that we seem necessary. As a starting point, there is no clear answer in how law could actually regulate or design for adaptive governance. In some areas of law, it has been designed as a kind of a programmatic approach, which you may find back in the EU directives, for instance, the Water Framework Directive. This means that cyclical and evolving plans and programs are used as tools for attaining environmental goals. Now, adaptive governance does not always require this kind of approach. Very often, it is the existence of vaguely defined objectives, a high degree of administrative discretion in the legislation that actually allows adaptive management to be an option. But there is a need for a much more systematic and coherent way in how we design for adaptive governance that on the one hand enables adjusting governance to new knowledge and understanding through coherent timeframes, coherent indicators, requirements for public participation, monitoring frameworks, information sharing requirements, and so forth. While on the other hand, it's important that this also remains to abide to the rule of law values such as predictability, legal certainty, and transparency. And that's often a very difficult balance to ensure. Now, all that I have said until now is actually something that could be applied to all kinds of transboundary marine ecosystem. But when it comes to the Arctic, the Arctic is a very good example of a marine transboundary region which is highly complex. It's regulatory complex, which we have heard from Geir already. And it's also an extremely important ecosystem in terms of the value it has for other ecosystems and for the communities living around it. The Arctic Resilience Report emphasized that it's one Arctic, but there are many different pursuits and perspectives on the region. For some, it's their homeland. For others, it's a source of resources, and it's a part of the global system of climate regulation. But there are different perceptions of the Arctic that lead to fragmentation. Different aspects of the region are experienced, observed, managed, governed, and planned separately. Ecosystem-based governance is highly needed in the Arctic, and several legal instruments and conventions also require this. The Arctic Council really promotes ecosystem-based governance as an overarching principle and approach for the Arctic. And the report, the 2016 report, says that as there is only one Arctic, all parties must share responsibility because activities pursued in one place affect what is possible elsewhere. And the Arctic can accommodate very different pursuits, but only to the extent that they are compatible, or else separated by enough time and distance. And this compatibility is very relevant, and especially when you think about the role of law, legal design is important here. The design of legal systems applicable to the use and the conservation of marine ecosystem is what actually crucial for its protection. This is my final sentence. It's the 2015 idea from the Arctic Council Working Group on the establishment of a pan-Arctic network of marine protected areas, which is a great example of a development aiming at a more ecosystem-based governance in the Arctic. But what they found was that there is a major challenge, and that's that there is such a great variety in governance regimes across Arctic states. That states may have very different regulatory approaches and legal criteria for both the designation of marine protected areas as well as the management of these areas. So it's difficult to operationalize because of the diversity and the lack of coherence between how Arctic states approach Arctic marine ecosystem governance. So the final wording on this is that coherence doesn't mean that we do things exactly in the same way, but the way we do things should be compatible and coherent in light of an overarching principle and a shared vision which sets kind of limits for human enjoyment to ensure long-term functioning and integrity of the Arctic marine ecosystem. Thank you.
Thank you very much, Froukje. And this is a true challenge, of course. So when we develop the strategy for the university, this will be one of the goals we'll try to reach.
Yes.
Thank you. Our next speaker coming up now, that's Professor Kristin Asdal from the TIC Center, the Center for Technology, Innovation and Culture. She works very interdisciplinary, I would say. Science, technology studies, political science, economics, and everything. So, and I think that she's also publishing soon a book about the good economy. What that may be, we're very excited. Anyway, the title of your talk is The Good Economy, Cod, Capital, and the Great Transformation of the Ocean. So please.
Thank you so much for inviting me once again to this Arctic Day event. I will start by reading. Far, far to the north, above the Arctic Circle, its southern border hemmed in by the lands of Norway and Russia, lies the Barents Sea. It is a place of extremes, a liminal liquid territory where in summer the sun never sets, while in winter it never appears. Seen from the metropolises of the world, it is a space that stretches beyond the margins of civilization, an unruly place not easily mastered by humans. For the Atlantic cod, a codfish that also goes by the name of Gadus moroa, or the Norwegian name skrei, the Barents Sea is a perfect place of dwelling. However, Always cold and teeming with prey, it is home to millions upon millions of this temperature-sensitive fish. Here, the largest remaining cod stock in the world spends the cycle of the seasons in vertical migration between warmer and colder layers of the ocean, going deep down when the nutritious surface gets either too hot or too cold. Were it not for its sexuality, this migratory cycle through the temperature layers of the ocean would be the cod's life. But when its reproductive hormones kick in, so does its horizontal wanderlust. In the dark of winter, the sexually mature codfish will venture on the many hundred kilometers long journey from the Barents Sea to its breeding grounds along the Norwegian coast. In fact, it is this journey that inspires its Norwegian denomination skrei, which stems from the Norse word skreid and is not so unlike the English word stride. The name skrei is also what sets this strider cod apart from its coastal kin. The fjord cod, which often belongs to specific fjord systems and which spawns locally, together with the cod swimming in the oceans of North America, Iceland and Greenland, these fjord cod and the skrei make up the family of the Atlantic cod. So this is how we start, as Ola mentioned, our upcoming book. My co-author Tone Huse and myself in the book Good Nature, Cod Capital and the Great Transformation of the Ocean. It's coming out at MIT in their Inside Technology series, hopefully next year. The book, which is one of the results of a 5-year ERC grant, does not set out to map and trace the codfish so much part of a natural system or a regulatory system or a judicial system that we have been hearing a lot about today, but rather the practices and the little tools, as we call them, by which the codfish is being economized. That is rendered an economic object and being made a part of an economy. And we also kind of struggle and search for ways in which we can cater for the ways in which the codfish itself, so to speak, struggles against also sometimes these ambitions of economizing the cod. So in doing this, yes, what do we do when we try to do this struggle? We follow the codfish around into laboratory practices and experiments where the codfish is so tamed and domesticated. We work with scientists and we travel out into trawlers and landing stations where prices for cod are negotiated and in part settled. And further also far and far out into Chinese mega markets and seafood markets where the cod is there to be bought for an ever-growing Chinese and global market. But we also travel into assumingly much grayer and dry sites and places, such as policy documents, innovation strategies, white papers, and Norwegian NOUs. Our method is multi-sited ethnography and what we call practice-oriented document analysis. And our study is ordered by by the broader theoretical and conceptual and analytical gaze of valuation studies. So thus this is a quite different Arctic from the Arctic that we have learned from Geir and the Arctic that he delineates in his study Norsk Polarhistorie. Here, the Arctic and polar research was defined as a study of nature and culture in the Arctic and the Antarctic. Hence, a study of a region, so to speak. A region that was slightly different from studies of other regions, as the contributions from the natural sciences were much larger than the cultural sciences, Hestmark notes, due to the simple fact that this region was largely unpopulated by humans. To the question then, where is the Arctic? Our answer would be on the move. And to see the Arctic as a region constantly being set on the move, worked upon and inserted into the economy. And moreover, obviously, that the Arctic also works upon us. And also, if you were to push me on this question, I would argue that we need to shift our national narrative even from a farmer's nation to a fisher nation, and that if we are to understand the emergence of our distinct version of democracy, we need to look to the role of the codfish and the fishers' opposition in the 19th century of the Storting, just as much as the farmer opposition of that Storting. But that is another book and another story, and that was also what I told about 3 years ago when I was at the Arctic Day then, so I will not go into that now. So let me rather kind of turn to the Arctic on the move. Because today I do not intend to turn to the Atlantic cod in much or more detail than I already did, but rather turn to the economies of which living species like the Atlantic cod is made to take part of, to the question of how to possibly trace and analyze such economies, including how to detect the trouble and concerns these economies are also accompanied with. So I will move from good nature to the good economy. And in doing this, I will draw from a recently published paper by our Good Economy project team, an ERC grant project that has just ended, which was just recently published in the journal Biosocieties. And the title of that paper is precisely what I will go into here. The Good Economy, a conceptual and empirical move for investigating how economies and versions of the good are entangled. So how economies and versions of the good are entangled. So the question that we are all now confronted with almost at a daily basis: what will come after the carbon economy? What will follow the fossil era? In the last 10 to 15 years or so, initiatives from key institutions such as the OECD, the EU, as well as individual nation states like Norway, have proposed and promoted answers to these questions. And interestingly, they all point in a similar direction. After the fossil economy, another economy must come. And the name of that economy is almost always a bioeconomy. In what is being proposed as the new bioeconomy, the bio is being used, interestingly, as a shorthand for various ways in which biological materials, such as marine species like the Atlantic cod, are and can be enrolled in economic practices and made into the basis for this bioeconomy. The various policy strategies enact the new bioeconomy in different ways, yet they all seem to share a strong normative basis, a vision of a shift to a new economy that is innovative, that is sustainable, that is responsible, and environmental friendly. In short, it is novel, ethical, and good. So these are just a few examples of these recent kind of documents that have been presented to us in the last 10 or 15 years or so. I will not go into this in any detail. I will just have to give you some kind of overriding arguments from what we have kind of analyzed and found. Because interestingly, what we find is that what is made to be good in the bioeconomy is quite radically different than in economies of the recent past. So what could that be? Whereas the good economy of the early oil and aquaculture economy, the Norwegian one I'm talking about here, concerned how to insert this economy into society in a good manner, society is surprisingly absent in the contemporary bioeconomy. So society is surprisingly absent. So that is already a concern. And so our argument is that the bioeconomy is put forward, enacted, as an expert issue. It is not put forward as a societal issue. And in being put forward as an expert issue, it is also to be pursued by the tools of a particular form of expertise, which is very much a form of economic expertise. And based in the idea, and that is also interesting, is that it is the bio itself, so to speak, that makes the economy, and any economy, good. So it is the bio that is, in a way, the kind of the good in this form in the bioeconomy. So just to say almost the same in a slightly different way, rather than an economy inserting itself into society, the bioeconomy is oriented towards inserting the bio in the economy. So it is this kind of bioeconomy relation that I'm troubling here and which is my concern. So the question then is, how is the bio to be inserted into the economy? Very much so by being ascribed the correct price. So just kind of to go a little bit into one example, we can look at the example of the ocean strategy of OECD from 2016, the Ocean Economy 2030. This report very much invests hope in that economic growth will be balanced up correctly against the long-term gains of conservation due to the deployment of a complex series of price-setting mechanisms. So it's not kind of the judicial or the regulatory or kind of the biological, so to speak, which is directing these strategies, but it's very much so a complex price-setting strategy. So the promise then is that the tools of evaluation of economics will secure that nature is being ascribed the correct price. So in this way, nature is brought into economics and simultaneously is becoming an issue for economics and economists. Thus, the ocean economy, as I just mentioned, is becoming by this an expert issue. In fact, the ocean economy will become good only insofar as these tools of evaluation of economics are put to use. Moreover, the economy is good only insofar as nature is being economized. The good economy is becoming a fully economized nature. So just to kind of stress this a little bit further, the insertion of the bio into the economy is not envisioned to happen by societal or political means, but by the way of the tools of evaluation of economics. Either neoclassical economics, such as ecosystem services or business school models and strategies. And this is in itself an important feature of the bioeconomy, in both its green and blue version. Even more so, the bioeconomy is presented as if such insertions come without frictions and dilemmas. So they come, so to speak, without concerns. The bioeconomy is enacted as if it is unproblematic in itself, and as if the bioeconomy relation is without tension, as the bio is made to stand out as the essentially good. And ironically, how to kind of let me just use a few seconds just to kind of compare and contrast this with former versions of the economy. Because ironically, this stands in rather stark contrast to the oil economy, in its Norwegian version at least, of the 1970s, which has now become the quintessential bad economy for environmental reasons. But if we look into this in other ways, we can see how this oil economy of the 70s actively pointed out and discussed problems and conflicts of interest that were likely to arise as this new oil economy was making its impact on society. The new oil economy could become a good economy, a qualitatively better society, as it was called at the time, and that could be the result of it. But in order for this to happen, this economy-society relation had to be actively steered and governed, since the opposite could just as well be the case and the consequence, if society did not have its hand on the process. So towards a conclusion, my first conclusion. The bioeconomy is often portrayed as something new, as an economy that will follow the economy of the present and the long-standing carbon economy. Obviously, this story can be told very differently. For centuries, the bio has been key to growth and prosperity, not the least in the Norwegian nation-state. Maybe the contemporary bioeconomy differs not so much in its bioeconomy relation, but just as important in its economy-society relation, and also in what the good consists of and where the good is located. And towards a second conclusion, likewise, there is nothing new to the fact that economies and the normative are entangled, and of scholars who study such relations. Think only of Max Weber and his notion of the Protestant ethic and the spirit of capitalism. And think also of E.P. Thompson's influential study and his notion of a moral economy from his studies of the English working class. Whereas Thompson, however, saw the moral economy as extra-economical, something outside the market economy, the notion of the good economy that we work with is suggested as a heuristic tool for investigating how different versions of the good and economies are entangled, and differently. And as a means to open up concerns and possible consequences, including for the Arctic and its movements into our economies. And then obviously, to conclude, the title of our upcoming book is thoroughly inspired by Karl Polanyi's book, The Great Transformation, The Political and Economic Origins of Our Time, which he published, written during the Second World War, and published in 1944. And he studied then on the rise of the land-based market economy. And so the question is, we could pose that question, is there, if not a similar, so a related move towards a great transformation of the ocean, and if this great transformation is eventually a fully economized nature of the ocean. Thank you.
Thank you very much. I really look forward to this book. It sounds fantastic. So, but it's also a bit complex, so I don't think we have time to discuss your conclusions here. We have to take them next year when we can read the book first. Thank you.
That's fine. Thank you.
Okay, then the last speaker in this section is Professor Jan Inge Faleide, and he's from the Department of Geosciences in the Center of Excellence, CEED, but he's a geophysicist, and he's been working with the Arctic in different relations and also then collaborating with Russian researchers. So we're looking forward to geology and politics, hopefully. Please.
Yes, that will be part of the story. We will now turn to Arctic geology. And I will do it in particular with a focus on the wider Barents Sea and the adjacent part of the Arctic Ocean. And I will also show you how closely linked geology is to law of the sea, and how much Arctic geology has gained from law of the sea activities among the Arctic nations recently. So this brings us subsea. It brings us very long back in time, in geological time, millions of years. And if we take a look at the Arctic Ocean, it's a very special ocean. It's enclosed by landmasses and wide continental shelves. These deep ocean basins, they're formed by continents breaking up, moving apart, by seafloor spreading, continental rift. And the first part that opened is over on the American side, so-called Eurasia Basin, that opened in the Cretaceous time period on the geological time scale, some 125 to 75 million years ago. For most of you, that's a long time ago, but for a geologist, that is rather recent. The younger part, on the other side of this elongated Lomonosov Ridge, we have the younger ocean basin that still opens. It's called the Eurasia Basin, and it's opened by seafloor spreading on a ridge in the middle of the basin that is linked to the spreading system that goes all the way down through the Atlantic. So the Arctic Ocean is surrounded by wide shelf areas, and of these shelf areas, the Barents Sea is the best known. And that's mainly due to favorable ice conditions, and by that also widespread exploration activity for petroleum in tens of years. The other part of the Arctic has very little data coverage because of the same ice challenges. But as I will show you, over the last 10 years, the amount of data has increased significantly, thanks to work related to the UN Law of the Sea. So, looking into the extent of the sea ice, of course, here's the explanation why we know so much about the Barents Sea, because of the warm water coming up the Atlantic. The Barents Sea is largely not ice covered. Of course, further back in time, this is the average ice edge in January. But this year in 2021, more or less the whole Barents Sea was open. In the late summer and fall, many of these shelves are ice-free, and for sure the Barents Sea shelf. So, as I said, these more deep blue areas, they are young ocean basins. And of course, if we are interested in the geological history, looking even further back in time, they have to be removed. We have to move back the continents that were there prior to the breakup of the continents. And doing that, we see that the Lomonosov Ridge ends up just north of Svalbard and Franz Josef Land at the northern rim of the Barents Sea. And we bring in elements from Far East Russia, Alaska, Chukchi borderland sitting out here now. And we see how closely they were linked to our side of the Arctic, meaning that when geologists meet, we see surprising similarities from what we can study on the Barents Shelf, subsea, or on Svalbard, which is part of the Barents Sea geology available in the field. And talking to geologists working on the other side in northeastern Russia or in Alaska, they look at very much the same type of geology. So then we can start to ask questions. This huge mountain belt, Himalaya size, that exists between Norway and Greenland, that continued up through the Barents Shelf. And how did it continue into the Arctic? Or if you are a geologist working with the Barents Shelf or in Arctic Canada, you see a lot of sediments coming by big rivers, draining a landmass up in the north. The Canadians call it Crocoland, Russians Arktida. But now we start to understand what was sitting up here not that long time back in the geological history. If you zoom in on the Barents Sea, it's a western part, the Norwegian part, and the eastern part, the Russian part. For a long time working in this area, we had an area in between, a disputed zone where Norway and Russia agreed to disagree. So for some 30 years, no relevant geological and geophysical data were acquired within that disputed zone. But still we could collaborate with the Russians, looking into the regional geology, but always we had to stay away and not do detailed work relevant to finding out what was hidden within that disputed zone. And as you know, geology crosses political borders, but it was challenging to tie together, link together the Russian part and the Norwegian part of the Barents Sea. But sitting down together, and we have done that for many tens of years. This is a list of projects only the last 15 years. Of course, our natural partner in doing so are our Russian colleagues. Working in the broader circumarctic type of projects. Of course, there are other partners also, in particular among the Arctic states, and Germany, which has a very long record in doing Arctic research. But working together with the Russian colleagues, being careful to do anything special in the area of the disputed zone, we could look at the regional geology. We could summarize what they see on the Russian side, we on the Norwegian side, and we see that the whole of the Barents Shelf in certain periods subsided, went down. In other time periods, they come up. In some time periods, they were squeezed together and deformed by compressional forces. And we see that there is something that affected the whole of the Barents Shelf. So there are many similarities, but also very large differences, in particular when it comes to what happens when we stretch, we extend the areas to form sedimentary basins and leading the way to continental breakup. And of course, being in the western part of the Norwegian Barents Sea, we have been part of the whole evolution of the Atlantic, and that is not much affecting the Russian part. So when we were tying together geology up to some few years back, we could do it. If we were looking at the broad picture, we are looking deep in the subsurface, but we have to stay away from the detail that could be relevant to hydrocarbon exploration in the former disputed zone. But of course then that changed. In 2010, the disputed area disappeared. We agreed with Russia on the borderline, and then suddenly we could acquire new, modern, high-quality data in the area of the former disputed zone, and then we could start to pick up structures that came across from Russia into the Norwegian waters of the Barents Sea, and we could acquire seismic data, what we use to look subsurface, to see what is hidden underneath the seabed, what kind of sedimentary layers and what kind of structures are hidden in that region. And suddenly we could be much more specific and detailed and also learn from each other on the two sides of the borderline between Norway and Russia. If we take a broader circumarctic perspective and look into what has happened over the recent years in the law of the sea context, of course, every Arctic nation looking for the opportunities to get beyond the 200 nautical mile boundary had to bring to the UN Commission on Law of the Sea documentation that it's possible to extend the continental shelf beyond 200 nautical miles. And to do so, they had to convince the Commission that the extended shelf they claim is a natural prolongation of their own shelf, starting by the coastline. And they had to argue for morphological and geological continuity, and as I will show you also, to how much sediments sits out in these deep water areas that really came from the landmasses of the individual states. All the data acquired for the purpose of bringing that documentation to the UN Commission was also immediately shared with academic institutions. And this has really been a major contribution to Arctic research and also international collaboration by analyzing these new data. So what kind of documentation is needed to convince the Commission, UN Commission Law of the Sea, that you can claim an extended continental shelf beyond the exclusive 200 nautical miles? And that is mainly related to a set of criteria or formulas. One is to follow from the shallow continental shelf down the slope into the deep ocean. You find the foot of that slope and you can go 60 nautical miles beyond. Alternatively, if that brings you further out, you can look at the sedimentary thicknesses in the deep ocean basin. And if that is more than 1% of the distance back to that foot of the slope, well, you can claim your outer limit all the way out into the deep ocean. Of course, you had to make some cutoff criteria here, because if not, some countries could really go and take the deep oceans of the world. So they decided to make two constraints in that respect. You can maximum go 350 nautical miles from the coastline, or you can go 100 nautical miles from where it's a water depth of 2,500 meters. So that means that you have to acquire a lot of geological data and morphological data to put together that puzzle that is behind the claim of each coastal state in the world. And of course, here we see what states can make claims in the Arctic. Norway was the first country to do so in the Arctic. We got the final recommendation from the Commission in March 2009, after approximately 4 years of interacting with the Commission to bring forward the necessary documentation. And as already pointed out in a previous presentation, that made us filling the gap between the 200 nautical mile zone from Norway and from Jan Mayen. Of course, the area in the Barents Sea was a bilateral thing between Norway and Russia, but we also did things up here in the north, to the north of Svalbard, going beyond 200 nautical miles from Svalbard, and that's the area with that at that time Foreign Minister Jonas Gahr Støre points at. That's where we, and if you zoom in on it, we see, and I will show you what kind of data was necessary to convince the Commission to get the recommendations. And that is to acquire geological and geophysical data that shows that this ocean basin, Svalbard sits on the right-hand side of the screen here. This is the shallow shelf, the slope, and we are far into the Arctic Ocean. All these colored units are sedimentary rocks that all of them come from the uplifted Barents Shelf, and they are so thick that we could use that criteria, the formula, that brings us further out into the Arctic Ocean. Also interestingly, and we did that work while we still had a disputed zone with Russia, but out here towards the deep ocean, we collaborated with the Russians because they were in the same boat, so to speak, because they will take over at the borderline here. They have to provide the same set of documentation to fix the continuation of that outer limit. For that purpose, they have to acquire the same type of data, and they have acquired a lot of data that we have shared, and we can see how they can use the same criteria. Will have a rather easy going for some distance further to the east here. There are other parts of the Russian claim that they will probably meet more opposition in the Commission. That brings me to a few words about the new initiative that University of Oslo is part of. It's called Go North, Geosciences in the Northern Arctic, which is a new cross-disciplinary program to investigate the Arctic Ocean. We are 13 Norwegian research and education organizations, and we will look at both the subsea floor geology. We will look at the water column, the surface sea ice. We will also combine new cruises into the Arctic Ocean to test new technology. And there's also an educational component in this program. It's organized into a set of work packages. The three first of them relates to geology, how the continents were rifting and break apart, how this spreading ridge, the present day spreading ridge in the middle of the young part of the Arctic Ocean that links to the Mid-Atlantic ridge system. Up here is the slowest spreading ridge on Earth that also enters into the continent over on the Laptev Sea side. So it's a very interesting from a basic research point of view to understand what processes operate at the plate boundary, at the spreading ridge that are spreading so slow. The third geology package goes more into paleoclimate. How has this basin or this Arctic region developed from greenhouse, hothouse, a few tens of million years back in time, to the icehouse, where we see the development of big glaciations and ice sheets covering all the shelf areas surrounding this area. Combined with these three geology projects, we will have development and testing of new technology and procedures for Arctic geoscience operations. A group will work in the water column and with the sea ice. Another group with the marine ecosystems and the change up here. And recently, there's also a geopolitical work package added to Go North. There are new cruises planned for the coming years. Next year, to 2022, a cruise with the ice-going research vessel Kronprins Haakon is scheduled to the north of Svalbard. And the last piece of the funding came in place yesterday with the added bill to the state budget. The government gave us the remaining millions we needed. So now we will leave for that cruise in 2022. In 2023, we have very specific plans to do a joint survey farther into the ice to the Gackle Ridge together with the German research vessel Polarstern in a two-ship operation. And the year after, in 2024, the plan is to meet the Swedish icebreaker Oden north of Greenland and do a survey back towards Svalbard. As part of Go North, there have been different research project initiatives, and one of them that successfully got funding from NFR in the last round is led by us here at the University of Oslo. It started formally last week, so we are in the process of hiring PhDs and postdocs. It will last until mid-2025, and the partners are University of Tromsø, University of Bergen, and NORSAR. And this project will in particular look at the 3 geology work packages already defined as part of Go North. So we will be working mostly here north of Svalbard into the Arctic Ocean and look at these processes already mentioned, how the continents break apart, and how the ocean basin evolved, and how the paleoclimate changed from greenhouse to icehouse throughout the last few tens of million years. And the new data needed for doing this project will come in with the 2022 cruise with the Kronprins Haakon to the area north of Svalbard next fall. So in the first of these work packages in the new project, we will look at how the Arctic Ocean here was born, how it initially opened some 56 million years back in time. Lomonosov Ridge was part of the Barents Shelf before that, then it separated. At the same time, there was a mountain belt coming from North Greenland into Svalbard. We open more of this ocean basin, and we also start to communicate with the Atlantic. So this is the present day, where we see how the Arctic Ocean is linked through the Fram Strait into the Atlantic Oceans west of Svalbard and further down along the Norwegian margin. So we will look at the breakup processes. We will also see how the basin developed in these few tens of million years up to recent. We will also ask ourselves how pre-existing structures, geological structures, what role did they play when the continents broke up? And how sharp is the transition from the continent here and into the ocean? That can tell us something about the processes, how this developed. We will continue out into the deeper part of the oceanic basin and look at how it was filled by sediments and at what speed it opened, and whether there's distinct changes in the opening rates, spreading rates, and what could be the explanation for that. And finally, by studying the sediments, they have the record that tells about how climate has evolved throughout the geological history, how we can go from a hot scenario in a greenhouse setting, much warmer than today, towards the icehouse in the last few million years. And how that change from greenhouse to icehouse is related to how the Arctic Ocean developed, how it was linked to the Atlantic, how the big current systems operated and played a role in the glacial history of the area. All these sediments that I have pointed at, they are filling in the Arctic Ocean, and they're also filling into the Atlantic Ocean. All these sediments, enormous volumes, they came there from an uplifted and eroded Barents Shelf. So for some part of the history, the Barents Shelf was up in the air, it was eroded, and what was removed here, up to 2 to 3 kilometers of sedimentary rocks, ended up in the west or up in the north. That happened and started prior to the glaciations, that's for sure, but also the glaciers, they also shaped the morphology of this shelf. So if we look at the Barents Shelf, we see clearly how the morphology of the shelf, set up drainage patterns that brought sediments first by rivers, later by wide troughs on a shallow sea, out to the continental shelf edge and into the deep ocean. So huge sedimentary fans are deposited west of the Barents Shelf and to the north of it. This is not a new idea, because already mentioned several times, Nansen, more than 100 years ago, he looked at the morphology of the Barents Shelf and he saw a shape and morphology and indicated in particular systems moving to the west. But we also now see that it happens up to the Arctic Ocean as well. So what we will be doing now is to plan for the cruise, upcoming cruise, where we want to go north of Svalbard with Kronprins Haakon, the new Norwegian icebreaker, and collect the data we need for the so-called dipole project. And perhaps I can report on that a bit later. Thank you.
Thank you very much. And I also learned from Brit this is the first Norwegian-led true expedition since Nansen.
Yeah, we have this professor in Bergen that went with a hovercraft in there on his own a few years back.
That cannot be an expedition if it was on his own.
This is this is the first real expedition, yes.
So we'll love to hear more about that when you come back, whatever that year was. Yeah.
Yeah, 22 in the fall.
Okay.
Next year.
Thank you very much.
Our first presenter now is Professor Olav Schram Stokke. He's a professor of political science at the Department of Political Science. And Olav, you are ready somewhere? Yeah. He is also a research professor. There you are. At the Fridtjof Nansen Institute, and where you have also been research director for many years. Olav's area of expertise is international relations with special emphasis on institutional analysis, resource and environmental management, and regional cooperation in polar regions. So in his presentation, Olav will report on findings from an international cross-disciplinary project on whether and how climate change poses challenges to the international management of major fish stocks in Arctic and Antarctic waters.
Okay, thank you for the invitation. I will just say 2 words about the project, so I don't pretend to have come up with all these ideas myself. This stock shift project is a 3-year project. It's now completed. The things we asked, the questions we asked, are about marine stocks, fish stocks mostly. And we tried to come up with good answers to in certain selected cases, polar cases, as to 3 things. First, what spatial shifts in marine stocks are underway? What do we know about these changes in migratory patterns or areas of distribution that have occurred and that is being linked to warming water? And then we ask a more kind of political question. How do these changes, what kind of challenges do they pose, those shifts of marine stocks, for existing management arrangement? And the third question, are those existing regimes, and we focus particularly on international ones, are they resilient to such challenges? With institutional resilience, meaning are they able to adapt sufficiently to whatever inadequacies or problems that they meet as a consequence of changing migratory patterns or distribution. Now we conduct certain case studies that involve both political analysis and modeling of biological, oceanographic modeling, climate modeling, in a set of cases, set of management area governed by international institutions. 2 or 3 in the northern seas, that is the Barents Seas and the Nordic Seas, Norwegian Sea, Icelandic Sea, Greenland Sea. That's a common term, the Nordic Seas, and a second area in the Southern Ocean, governed by a piece of conservation machinery under the Antarctic Treaty System, CAMLR. These cases are, well, there's a selection of institutions here, but they're also in some interesting ways representative of the kind of regimes that we see all over the world. In the Barents Sea, we have a bilateral regime dominated by the coastal states, Norway and Russia, with others also taking part, but with the dominance in the two coastal states. In the Nordic seas, we have a multilateral arrangement that has a relatively weak institutional basis. There's a set of agreements at regional and bilateral levels. Whereas in the Southern Ocean, we have a more traditional regional seas management organization that has an unusually strong division among environmental interests and fisheries interests. Usually the fisheries management regimes do not place strong emphasis on environmental concerns, but Kamalar does. So we have three cases that we do in some depth. And they are representative of an interesting diversity of situations, of management regimes facing a warming ocean and stock changes as a consequence from it. So the project, funded by the Research Council of Norway, was directed by us at the Political Science Department, but we included a number of natural scientists, both from the biology department here, the CS Group Center, and also the Marine Research Institute in Bergen, which has has access to the world's best data on fish stocks changes, also temperature situations in the Barents Sea. In the group of those who have the best of data in the Nordic seas, and also leading data collection and analysis regarding krill in the Southern Ocean. So pretty good team of participants, and as well as legal and political science scholars from Norway, Netherlands Institute of the Law of the Sea, and the USA with Orrin Young from the University of California, Santa Barbara. Let me say, in this Glasgow periods, it's important to take some caveats regarding the setting for the political things I will talk most of. It's certainly the case that the effects of these warming oceans on fish stocks and on fishers is not only negative. It's quite clear that at least the short and medium term implications in the northern seas are that we see enhanced bioproduction. Warming water has that effect. It's much more unclear whether the effects on the commercial stocks will be positive because of the interspecies interactions that we don't really know how will play up for those stocks that we rely on most heavily from an economic point of view. The effects in the Southern Ocean, of a warming Southern Ocean, are rather clear. It seems to be that all models predict that the habitat situation for krill, the biggest commercial stock being exploited there, will deteriorate, perhaps even drastically if the modeled changes in temperatures continue. There are, however, climate is not everything. There are many other determinants of spatial shifts of marine stocks. Bottom topography, something that Kristin Asdal mentioned too, her opening reading was about the Barents Sea being the perfect dwelling for cod. So the bottom topography is a very important determinant of whether a warming ocean will cause stocks to go elsewhere or to expand their area of distribution. For instance, cod, well, partly due to its reliance on the sexual drive that she mentioned, the look for good spawning areas will probably it's been restricted in its northward movement due to that. Fish, like us people, we have the kind of temperature comfort zones. So if it gets too warm, they tend to go further north, perhaps. But they have other needs as well, partly sexual ones and partly access to food. Stock size, another very important determinant of whether warming oceans will cause shifts. It's pretty clear today that the much stronger driver for this very big change that has occurred in the mackerel and also part of the herring stock in the Nordic seas is caused largely, mostly, the biggest driver is the increase of the stock itself rather than the warming water. And again, climate-related stock shift is nothing new. Already in a publication by two gentlemen who were mentioned in the first lecture this morning, Helland Hansen and Nansen, stated already more than 100 years ago that changes in ocean temperatures likely to be the primary cause for the fluctuations that scientists and fishers were highly aware of already then. Shifting availability, moreover, in stock, differences, big changes from year to year and over longer periods regarding the availability near the coast was, of course, a major driver for the development of fishery science, with Johan Hjort as one of the pioneers. Seems to be a kind of the thing that should be seen at the bottom there is that rather than seeing the stock shifts that form the starting point for this lecture as the driver of rather than seeing climate changes as the driver, it's rather the case that climate changes, warming oceans, tend to reinforce certain challenges that are generic to fisheries management in all situations. So the question about resilience is then, how do such changes in challenges, increasing challenges to resource management, how does it affect the effectiveness of management? And we focus on three aspects of management. One is what we call the cognitional resilience, which has to do with the ability of this regime to develop and provide advice on scientific basis for what kind of measures should be taken at national or international levels. And the problem that stock shifts can cause for this important management task is that if there are big changes, then it's likely to arise, and it does historically arise, competition about who should have what parts of the share, and if the fish moves, becomes more available in other zones where they have been historically, then the issue of how much more and how fast is this, how durable is this, are scientific pieces of information that have political implications, affect the interests of state. And the risk immediately arises of politicization of science, pressure on national scientists to somehow emphasize criteria for zonal attachment, for instance, that are more favorable, more conducive to the interests of their home government. We see traces of this in the case of the mackerel management as a consequence of the big shift westward and eastward into Icelandic and Greenlandic and also Faroese waters that occurred some 10, 12 years ago. This kind of politicization of scientific advice has the effect of reducing the legitimacy of scientific advice, the kind of persuasiveness that the science has on policy. In the case of both mackerel and herring, the two pelagic stocks where shifts have been the most extensive, that credibility or persuasiveness has also suffered from a long string of advices regarding how the stock is likely to develop that have been relatively poor predictions. So that's some things you might expect when there is big changes in the conditions for the stock. It's more difficult to predict how big will it be, how strong, how sensitive is it to levels of harvesting. But it has the effect of reinforcing this kind of problems of legitimacy and credibility on the scientific advice side of government. Our studies show that the resilience of these institutions is nevertheless high to these changes that we have observed. The science bodies They try to incorporate impacts of science, of climate change, into their modeling and into their advice. ICES, which is the leading institution for providing advice in the northern seas, does provide not only recommendations regarding how much fish should be taken, but even provides information that's relevant to the much more politically sensitive allocation question. Reporting on changes in zonal attachment, for instance, for the most politicized stocks too. So the system of advice functions. They attend to the kind of issues that the regimes are dealing with and kind of questions the policymakers would like to provide answers on, scientifically based answers. So it works. This, we argue, is explained mostly by the institutional strength of this advisory body. It has a more than 100-year reputation for a high degree of impartiality, which is supported by very rigorous peer review procedures. Much weaker so in the Southern Ocean case. The Camelar Scientific Committee is considerably more politicized generally. This follows from the big conflict between conservation or preservation interests and fishing interest in that particular institution. But it's nevertheless the impacts of climate change and the acceptance, the recognition of that phenomenon in Camelar practices has nevertheless stimulated more data collection, more and a better analysis of the state of the krill stock. So the lesson here is that one should, in order to remain resilient, it's very important to be very careful about any things an research scientific body does that can jeopardize its integrity or credibility, because that credibility will be particularly important if there are big changes that have to be dealt with, and where credibility has to be maintained despite politically controversial issues being discussed. Now, looking at the regulatory side, the impacts that climate change, stock shifts is having on the ability of regimes, states negotiating annual quota agreements, is that it can complicate those negotiations. It can make it more difficult for them to reach the kind of agreements that they must reach each and every year. There are, especially if there are shifts in zonal attachment, where the fish becomes available in EZs which has not been taken before, as has been the case for mackerel in particular. Practically no mackerel taken in Icelandic waters or Greenlandic water, hardly in Faroese waters back before 2002, 2003, and then all of a sudden a large portion, sizable portion, could be taken in those zones. And then you meet a situation where you have to accommodate new entrants to the fishery, or at least existing entrants, to say that we should have much more in the past, of course complicating annual negotiations. Much more difficult when these things are in a flux than if they are stable. The situation regarding regulatory resilience for the regimes we're talking about is very varied. In the pelagic stocks in the Nordic seas, regular failures. Since 2009, around 2009, none of these years have been able to. The states have been unable to reach comprehensive agreements regarding the amount of fish to be taken of these pelagic stocks and how to share them among themselves. So you get unilateral quotas that sum up to a total catch that's much higher than what has been advised from the scientists. So but just to illustrate the amount of overshoot in terms of actual quotas compared to the advice, around 40% on average in the case of mackerel. And you see a very different situation in the Barents Sea, governed by the Norwegian-Russian Joint Fisheries Commission. Here you see a strong and steady regularity in annual agreement. You see quotas, total allowable catches, that are on level with what is advised by the scientists, and you see no challenge to the 50-50 split that Norway and Russia have agreed to ever since the years of the Soviet Union. So you see stability and resilience regarding the most important stocks. The explanation we find for this big difference is mostly malignancy, but also institutional strength. Malignancy is a term just referring to that some problems are politically more difficult to handle than others, and therefore two institutions that are similar in strength when facing that political problem, they are likely to fare differently if the problem is more severe. Climate change in itself as a kind of problem is a very malign problem because there are weak and often uncertain incentives to deal with it. In the case of fisheries management, such malignancy has to do with the incentives that states have to enter into agreements among themselves regarding long-term division, sharing of a stock. And in the case of mackerel, for instance, herring, the same thing. The interest that the newcomers, Iceland and Greenland and the Faroes, had in reaching agreement with the existing players, Norway, EU, to some extent Russia, was very low because they had at the outset practically nothing. They could gain much more from staying outside the agreement than by entering into negotiations with the old-timers who did not consider them as legitimate participants. So in that situation, the ability to overcome that malignancy, that the big political problems they face, it was a big challenge, and the institutional strength that the pelagic regime had to meet that difficult political problem was much weaker than in the Barents Sea case. In the Barents Sea case, you have a bilateral regime, you have established harvest control rules. That means that the scientists make recommendations that are more or less automatically translated into total catch, and then you have allocation keys that are more or less fixed. Easy thing, more a matter of calculation than negotiation. In the pelagic regime complex, you have a series of bilateral regional agreements with very weak harvest control rules, emerging only gradually, and no fixed allocation rules in practice. So that's a situation. The lessons we may draw from that is that one should seek this kind of regulatory decision rules that can facilitate annual negotiations. But one should not opt for the very strong ones that you have in the Barents Sea necessarily regarding allocation, because in a situation where there's big changes, big flux in the underlying political realities of who can manage well without the agreement, then that is not realistic. But you should opt for at least somewhat more medium-range decision rules. Very quickly on the compliance resilience, I see some elements of impatience in the Brit Lisa. The situation here is that compliance, the kind of systems of verification, review and response to violation of rules that are in place under international fisheries management systems, they can get enfeebled, can be challenged by big changes in stock movements or distributions, whenever that leads to greater availability of the fish on high seas water, where the basis for inspections, enforcement is much weaker. Nevertheless, what we see is relatively high, or very high, compliance performance in all the polar regimes that we study. There's little evidence of overfishing quotas, partly because those quotas, in the most difficult cases, have been set very high, higher than, or perhaps even at the level of what the fishers are capable of taking. That's one of the reasons. It's a low malignancy compliance problem. But it's also explained by the strong institutions that have emerged during the past 15 years, in particular, in connection with the fight against IUU fishing, illegal, unregulated, unreported fishing, with satellite monitoring system, catch and trade documentation scheme, kind of a control system that makes this side of management relatively unvulnerable to stock shifts that even when they are substantial. So in short, stock shift vulnerability varies considerably across these three essential management tasks. institutional design, which is governance, which is something else than just something happening, as Ola now will know. Now will be able to tell next time he speaks about governance. Governance is, of course, the making and strengthening of norms and regulations. So it's that kind of activity. If it's not that kind of activities, you cannot call it governance. It matters. It matters for resilience and for the reasons that I've just mentioned. But we should also warn that malign problems, like the one we have in the Norwegian Sea, sets limits or impediments for building strong institutions as well. So thanks for your attention and thanks for your patience.
Okay, thank you, Olav. I don't think we have time for questions, but I think we'll slide over to the next presentation, which is by two persons this time. And it's Sissel Jentoft and Joël Durand, which both are researchers at the Center of Ecological and Evolutionary Synthesis, CEED. And Sissel, which is, I can take Joël first. His main interest is the research area is the effect of trophic interaction, climate change, and human activity on wild population dynamics. And Sissel, her main interest is the effect of trophic interactions. Evolutionary marine genomics. Okay. And both of you are working within Arven etter Nansen, Nansen Legacy, which is maybe the largest Arctic research project in Norway these days. So please, Joel, you can start.
Yeah, thanks a lot. Yeah, so here we are. So thanks a lot for coming today and for listening to us. After the very interesting presentation with a lot of text, you will have a lot of photos. There's still content. Okay, so we discussed about the Nansen Legacy. So here at the Nansen Legacy, it's a big project. It's about ice, it's about Arctic. It's about following what this man did some years ago. You know him, so I won't make so much detail on it, and I will go to the content of the presentation. So where are we? Since I know this is not working on camera, North Pole is here, the Barents Sea is here, and we are speaking about the Barents Sea. The Barents Sea is a very interesting place. Very interesting place because not only because it's on the coast of Norway, of course it is, but also because it's twice a sea. You have the warm water coming from the sea, coming from the Atlantic. This is the red arrows that you see coming inside here. And you have the cold water coming from the Arctic, from the north, the blue lines. And they are mixing at some point, creating a front. And this is very interesting because the cold water means ice. Warmer is the temperature, lower ice you will have. Colder is the temperature, more ice. And that's the start of what we will talk today. If you look on the southern coast, you will have open water. This is a photo taken in Kola, in the Russian side. And if you go in the north, you will get the sea ice. And here you have a photo of the Kronprins Haakon, the icebreaker that Nansen Legacy is lucky to be able to use to go and sample in the ice toward the north. So what do you see with climate change? We see this curve here. This is from 1985 to 2015. It's not a big surprise to one who don't know how to read a curve that is going down, there is less ice. The Barents Sea, that usually was quite covered in ice during the month December, May, it was the longest sea ice extension on the winter, is becoming to have much less ice, meaning that the front that I was speaking earlier is moving northward. And this has created a lot of change. Here you see what's happened in 2004 and in 2012. So you see that was the reduction of ice in between, if you remember the previous slide. You have in red some fish that we call Atlantic fish that are used to kind of warm water. And you have some fish in the Arctic fishes on the north in the blue ensemble that are very inferior to the ice, that need to be in the cold water. This is a picture in 2004, and this is a picture that you see nowadays. So more and more, the species that are used to warm are moving northward, and the area where the species that are linked to this ice, to this cold water, are reducing. And this, you have an example here of two species, the two zooplankton. You have here the copepod, and you see the line is decreasing with the years, and the same for the amphipod, decreasing with the year. So these species are less abundant nowadays than they were. And this coming to the hero of the day, the polar cod. The polar cod, you have the scientific name up here, is also sometimes called Arctic cod in US side of the world. And this, if you see this figure here, to understand it is easy. You have an arrow. The arrow is coming toward another species, and the one at the top of the arrow is eating the one at the bottom of the arrow. So what you see is that the polar cod here is very important as a prey for several species. The seabirds, we have many seabirds around the coast of Norway, and if you see Novalia zemlya or Svalbard, there's a lot of seabirds here, and they're feeding on polar cod. The seal, and eventually, the one iconic fish that we have, the Atlantic cod, that is also eating the polar cod. And this is where you find the polar cod. So you remember Svalbard, Novalia zemlya, and the coast of Norway and Russia. The polar cod you find in the north here. And you see the abundance of the cod. The polar cod has increased at some time until 2000, 2003, and then since then the decrease of the abundance. This is higher the plot, more fish you find. And what you see here that I discussed just now here is that you have age 1, 2, 3, 4 is because the polar cod live around 4 to 5 years. After that they die of old age or die before being eaten or die of something else. And knowing this, that they live in a place where there's ice, knowing this, that they need this ice as an environment, some people were able to make simulation. And for example, the group of Sheng here make this kind of simulation with a kind of climate change scenario that we have. We start with finding the polar cod all around the Arctic, and more you go in years, it's decreasing. And in 30 years, with this scenario, it's disappearing. Nearly no polar cod in Arctic. That's the idea in 2008. And it's what we are studying. So now we have data. We have a lot of data. And there's two variables that we are interested in my part of the world. The length, how much the polar cod is growing from H1 to 4, and the abundance, how many there is. On this case, we make an analysis looking at the length. All these different elements, such as the prey that you have discussed, that the amphipod and copepod earlier, we said there was a prey, but the krill can be the prey of polar cod. The sea ice, that's what we want, and the temperature. And predation, cod can eat polar cod. If they're eating, they're not growing anymore. And we make models. So we make statistical analysis, making equation, telling us all the lengths of the polar cod can be affected by this, the food. And there are the results. The food is affecting basically only the H1, so the small one. But the ice, surprisingly, is affecting the other direction. Less ice, bigger the polar cod we find. But it's not a surprise in the sense that actually in the Canadian Arctic you find exactly the same. Here you see the ice breakup is earlier, meaning that there's less ice, so the spring is coming earlier. Smaller is coming later, sorry. Smaller is the polar cod, and if it's coming earlier, so less ice, is bigger. So this is maybe related to the fact that they have eventually, when the water is open, better condition to grow. But what about the abundance? We saw this curve decreasing recently. So we do the same. This time we look at abundance, the number. And then we look also at the prey. We remove the krill that disappeared completely on the previous equation. And we had the harp seal. We saw on the previous slide that, on the earlier slide, that it was eating the cod, polar cod. And there it's a complicated stuff, but in summary, what you have the ice here is affecting only the first edges. You have the predator, that is the predator that are the seal and the cod, the scray. They are affecting negatively the oldest edges. And then you have other variables such as the temperature, that can have an effect also. So what does it mean? That means here that we have different places, and the chord inside the polar chord is affecting at the different under the ice, at the bottom of the sea. But one question that we didn't answer is it a polar chord a polar chord? Is there one stock, several stock? And this we need to know then. So now you have the warm-up team that coming, and now you get the main dish, meaning the main speaker, Cecil, will speak about genomics.
Thank you, Joel. I think the modeling Joel is doing is super important, but to further our understanding on how a species and the ecosystems, not at least, are impacted by ocean warming. And as you can see, maybe not, in the Arctic it's impacted heavily, more than in other regions. So what we want to do within the Nansen Legacy project is to actually take advantage of the recent advancement within the high throughput sequencing technologies to uncover a more holistic understanding of the study organism and the ecosystems. So by doing a full characterization of the genomes of polar cod, that means we are characterizing the complete set of the DNA, including all of its genes. And by doing so, we aim at gaining new and additional information about the species and how it's actually responding to the ongoing warming in the Arctic oceans. So first, I would like to give you a short introduction to a previous study that we've done, where we did full genome sequencing of different codfishes, compared the results between those species, and then by doing so, we detected that the antifreeze glycoproteins preventing organisms from freezing in the Arctic originated from non-coding DNA, which coincided with the cooling of the northern hemisphere 14 million years ago. Additionally, when comparing these species, we also identified that the thermal specialists, like the polar cod and the Arctic cod, had a higher number of these genes than, for example, the thermal generalist, the Atlantic cod. Then moving into population genomics, where we are actually sequencing several individuals from within a species, for example, within a geographical range, with the main aim to detect similarities, differences between the species or the individual within the species, and then identify if we see population genetic structures and differences between those individuals that could be linked to spatial location where they live, the habitat, ecological and environmental conditions, as well as migratory behavior, if you have feeding migratory routes or spawning migratory routes. In addition to this, we also, with this population genomics data sets, can look into the standing genetic variation of a population and also infer their adaptive capacity, which is super important to understand how they are going to respond to climate change. And I would say that this is crucial information for conservation genetics and further development of management programs of these key species within the Arctic. So maybe I should start doing like you, Joel. So we have two regions where we think polar cod is spawning. One on the western side, close to Svalbard, and one on the eastern side, close to Novaya Zemlya. When we are looking then at the water currents, as well as think that they are potential having homing behavior, we speculate that we have maybe at least two subpopulations of polar cod in the Barents Sea area. To look further into this, we have now, during the past years, collected a lot of samples of polar cod, mainly focusing around Svalbard and in the Barents Sea area, along the Nansen Legacy transects here in the Barents Sea, but have also gained additional samples from the Russian side, Greenland, Iceland, as well as a few samples on the Canadian side. some nice photos out sampling in the Barents Sea in 2018 on the Krumpinsåkon. And here we have my PhD student, Siv, sampling the fish together with Leif Christian Stige. So now we have sequenced all these 290 specimens. And then we are looking into the genomic signatures of the fish. Here we can see that each bar is one representing one individual. And we do not see high genetic differentiation between, for example, the samples that we collected in Russia, quite surprisingly, compared to the Barents Sea samples along the Nansen Legacy Transect. However, we do see some weak population differentiation for the samples that we collected in Iceland, Greenland, and Canada. This is indicative of high mixing of the stock. So you have high gene flow between the different stocks. However, in addition to this, we also identify several putative inversions or other structural variations within the genome of polar cod. Here is exemplified on chromosome 10. We have a large block on this chromosome, which is actually highly differentiated between the individuals that we sequenced. So what does this mean? Why are they important? Why are the inversions important? It's an increasing number of literatures now diving into these structural variants and how they are influencing the local adaptation of a species. So here, to explain what is an inversion, is actually a segment of a chromosome which is flipped on one of the homologous chromosomes. This means that this region contains two different haplotypes, variants, where little recombination occur between them. So they are super important for maintaining differentiation between the individuals that we see in the Barents Sea. And to give you one example from the Atlantic cod system, why inversions are super important. Here we have compared the iconic Northeast Arctic cod feeding in the Barents Sea, moving down to along the Norwegian coastline, spawning in February, March, where it's teaming up with the Norwegian coastal cod, a stationary ecotype of Atlantic cod. And the only differences we see between those two ecotypes is actually those inversions. Rest of the genome is quite similar, indicating high gene flow also between the two ecotypes of Atlantic cod. So we are now scrutinizing the dataset, looking into these inversions even further to see and infer the importance of those in the polar cod system in the Barents Sea. And to summarize briefly, I would say that whole genome sequencing dataset, we can gain new and valuable insight into genomic differences, look into signatures of local adaptation, and also infer the adaptive capacity of the specimen or species that we are looking into. And then me and Joel have a goal that we want to combine the knowledge of genomic information into Joel's models, so that we can further enhance our understanding how important the genomic background is on the sensitivity of a species to the changing environmental conditions, and again, as I said earlier, to the development of sustainable management programs. And with this, I would like to say thank you, and I would then express thank you to my PhD student, Siv, and master student, Marius, as well as postdoc Nicholas on the modeling part.
Thank you very much to both Sissel and Joel. I didn't think I would learn so much about cod during this day, but I learned a lot on different aspects of cod, so thank you very much. Is there any questions to Sissel and Joel? Some clarifying questions? Then I think we should move to the last presentation of the day. And we started to look for in the future, and then we went back to the history, and then we have had a lot of presentation of present-day research. And as a last presentation today, we'll take one step back again and look at the researchers that was here before us. And the one to take us into this is Professor Hans Arne Nakerem. He's a paleontologist working at the Natural History Museum, a place where I happen to know very well last half year. His main research is the geological development of Svalbard and Arctic, and in particular with the use of fossils that may tell about the development of the environment. And he's also a true museum man, collecting samples. Well, collecting samples, taking care of samples, and this is also brought Hans Arne into the history of much of our research. So, well, you will.
Okay. Thank you very much for inviting me. As Brit Lisa said, yes, I'm a paleontologist at the Natural History Museum here at the University of Oslo. And being part of my research on Svalbard paleontology and geology, I've also studied the old collections which we have in the museum. So I'm also going even further back in time. You've seen this map, or pieces of that map a couple of times during the day. And this is Novaya Zemlya, the map made after Barents' trip to Novaya Zemlya, where he died in 1597. But his colleagues managed to get back to the Netherlands and report, and the map was made. So this is also a map of Novaya Zemlya. Up here is the place where the Barents died, and lots of North Norwegian sailors, hunters and whalers went up there in the 1860s, 1870s, and Elling Carlsen found the settlement of Barents. So that's the background. And I jump another 300 years in time to 1921, and I will talk about the Olav Holtedal expedition to Novaya Zemlya. First of all, he was a professor in historical geology at the University of Oslo for a very long time. He had field trips to Spitsbergen 3 times and to Bjørnøya in 1918. And that material he collected on the western part of Spitsbergen was the basis for his doctorate, which is Carboniferous and Permian geology and paleontology of Spitsbergen. At the same time, when he had this Svalbard work, he also received, or the museum received, material from the second Fram expedition to the Canadian Arctic, and also the material that Roald Amundsen collected on his way to Alaska. So Holtedal had all these collections together with the Svalbard and the Canadian and the Alaska material, and also the Novaya Zemlya material. So he became a real expert on Arctic geology. So we went to Novaya Zemlya in 1921, and further south to the Antarctic in later years. And in between, he was a president of the Norwegian Geological Society, and he was also writing popular books. Some small books, but the geology of Norway ended up being 1,128 pages. So some of these old guys really wrote big and interesting books. He applied for money, as we do today, from the government in 1919, 50,000 Norwegian kroner, but the application was turned down. But he received a lot of support from Fridtjof Nansen and Brøgger, Valdemar Brøgger. In 1919, 1920, he applied again, and he received 40,000 kroner from the Norwegian government. That's equivalent to approximately 800,000 kroner today. And that was enough for 8 weeks on a ship to Novaya Zemlya, in addition to private sponsors, food, tobacco, alcohol, everything they needed on the boat. Nansen did a lot of lobbying. I just found the newspaper archives at the Nasjonalbiblioteket on the internet, and you could search for all these articles Nansen wrote. So he wrote here in Norwegian, I recall no case in which a man has gone better prepared to a research expedition than he to Novaya Zemlya. But at the same time, in the newspapers like today, people argue against what's written. So, for instance, this is in Norwegian. A person called Ørjan Olsen didn't like what Nansen wrote in a very strange way, and Nansen replied very angry back in Aftenposten. So, most of you are Norwegian. Det virker humoristisk når herr Olsen, som ingen erfaring har i arktisk forskning, her underviser oss om hvordan en slik ferd bør foretas. So Nansen was very upset. And he also said that this note from Ørjan Olsen could be misunderstood for the less intelligent reader, which obviously herr Ørjan Olsen also belongs to, according to Nansen. So he was very upset. But Holtedal got his money. He went to Novaya Zemlya for 8 weeks. So these are the dates. Left Oslo in June, left Tromsø 10 days later from Vardø, and arrived at Novaya Zemlya approximately 3rd of July out here, and entered land on the 6th. And 8 weeks later, he returned to Tromsø. So I have some pictures from the glass negatives, which we scanned at the museum some years ago. So if you have Holtedal's publication and look at the picture, they took 2 pictures. The one in the publication, they look very serious, angry, and serious. But here you can see Holtedal is actually smiling. That's the second picture. Like we do today, take one picture and people relax. It took probably 10 minutes between those pictures. So Holtedal was a serious but smiling man. So they had this Blåfjell, this North Norwegian small ship with lots of smaller boats, lettbåter. So they entered land and fought against fog and bad weather. They brought with them lots of food, but they also, of course, they shot animals and had them for food and preserved bits and pieces, and they are now in the Zoological Museum. So you eat a bit and you take the rest with you to the museum. This is just an example that I cannot talk about every day here, up here, but there was a 7-day sledge trip across here, across the island. It took them 7 days, climbing up the glacier here and crossing to Sivolka Fjord. A long and hard trip, tenting on the ice, but they got their material, they found the geology they wanted. There were people already living in Novaya Zemlya. In the first popular scientific publication by Holtedal, he writes about this primitive urinnvånerne. which they were not. Not primitive and not urinnvånere. So in the last of his more public publications, he wrote about these people very differently. There were 2-3 settlements he visited, met these people, talked to them, and traded fossils from them. He gave tobacco, and he received fossils, which is a very good way of getting data, because especially these fossils are very rare in Novaya Zemlya. For you geologists here, these are Jurassic ammonites, and there are no Jurassic rocks in Novaya Zemlya, as far as we know. On some Russian maps afterwards, there are some bits and pieces of Jurassic rock. But both Holtedal and Nordenskjöld, 50 years before, borrowed or got these fossils. So another very beautiful ammonite, a fossil cephalopod, which is extremely good at correlating and dating rocks. We need these to understand the age of the rocks. So he collected quite a lot. So you see here, we have more than 4,000 fossils or specimens in the collections at the museum. Just an example, an Ordovician brachiopod published, and some corals. So Holtedal could compare. He recognized a lot of the material, the fossils, from what he had seen from the Canadian Arctic and from Svalbard. But he did not only collect geology. There were botanists, zoologists, and other people on the boat, so they collected botanical material and zoological material. These are, the numbers here are all specimens that we have in the collection at Tøyen in the museum. In total, they spent 8 weeks, and that ended up in 45 reports during the next 8 years. Extremely productive, especially in zoology. Mainly aquatic zoology. So the first one by Holtedal in 1922, and the last one on magmatic rocks in 1930s. Thousands of pages, actually, from those weeks. So what do we... I'm a geologist, I'm a paleontologist, so I focus on that. So what do we have here? First of all, Holtedal compared the rocks and the fossils, so he did a reconstruction of the paleogeography, very much like Jan Inge talked about. If we merge these continents together before splitting up, Holtedal understood the placement or the paleogeography, not necessarily plate tectonics, because it does not refer at all to Alfred Wegener's plate tectonic work. So still there were sea level changes and these geosynclinaler and things. But he could see that there must have been some sort of connections between these Arctic countries, from Novaya Zemlya to Alaska, via Greenland and Svalbard. So he was a paleogeographer. Of course, they collected all these fossils, and when you go to a new location in the world where no one has been before, you will most certainly find new species. So that was really one of the first descriptions of fossils from Novaya Zemlya, and there would be lots of new species. It's important to have these rocks, the understanding of Novaya Zemlya, like we heard again from Jan Inge and others, to have some understanding of the geology to the west, to the Barents Sea, and to the east, to the Kara Sea. This is like Svalbard up in the northwest Barents Sea. This is the place you go if you want to collect material to understand that part of the continental shelf. So in this museum collection where I'm working, we have lots of material for future research available. And some of these localities, of course, are rather inaccessible today. And why is that? Would you like to go to the central part of Novaya Zemlya and spend some week there in a tent? Probably not. This is the world's biggest hydrogen bomb, which they exploded there in 1961. This is the blast. They had many of these, and that part of Novaya Zemlya where Holtedal went is really destroyed by nuclear explosions. So yes, it's radioactivity in that area. And since Holtedal, he went up there just 3-4 years. 4 years after the Soviet-Russian Revolution, and it was not very easy to get permission to go there. So in the years after, until now, it's been more or less impossible for political and military reasons to get to Novaya Zemlya. But the material has been used at the Geological Institute, Department of Geosciences, at the University of Oslo, and at the museum. So for me, being curator of that collection, I find it satisfying to see that all the scientists come in and use our really old collections. So from geochemistry, fossils, and petroleum exploration as well. And the material has been used in a PhD and in a master project also at the Institute. And Holtedal is popular in Russia. His books are translated to Russian. Do you read Russian? Some of you maybe. Holtedal's ship was called Blåfjell. So this is Blue Mountain. Expeditia, Blue Mountain. My son is speaking Russian, so I asked him to translate, and it took me some minutes discussion with him to recall that, well, Blue Mountains, that must be the Arctic mountains. We had a discussion. No, of course, it's Holtedal's ship, Blåfjell. And this is an Arctic Russian historian who had received some photos and some information from me. So it's interesting to see my name in Russian, in very funny grammatics in Russian as well. So he is popular, like Nansen, in Russia. So a message to take home for all of you. Museum collections are relevant today, even if they might be old and dusty, because sometimes you can only go to these collections to find the material. The area might be inaccessible, exploded, covered by airports, anything. So it's important to take care of these collections. And sometimes this is appreciated also in lots of other journals and publications. So we have a catalog, if you're interested. It's 1,300 pages with photos and documentation of the collection. So, and finally, this is a picture from the old collection at Tøyen. That's me a few years ago. So this is the part of the Arctic collection in the old Geological Museum. We are now at Øken with the collection, much better facilities, but I also would like to welcome you to the new museum when it opens in near April, Easter next year. Thank you.
Thank you very much, Hans Arne, and for the good what do you say, yeah, moral things about taking care of collections and things like that, which we all should do when we are doing field work and such. I think I will just say to all of you, thank you to all presentators today. I think this day has been exactly how I wished that we have planned it to be. It's glimpse and presentation from all parts of the universities, and I think some of us must stretch our mind at some presentation because it's very different from what we usually are listening to, and I think that's good for all of us. I think they've all been very, very interesting, and I really thank all of you that have given presentations today. A big thank for your participation and contribution. And of course, thanks to our collaborators, the Science Library, that has done all these great things for us, and NIFS, Norsk Institutt for Sjørett, as it's in Norwegian. I never always forget the English name for it. So, and of course, the Arctic Committee at the university. So next year, there will be the 6th Arctic Day. It will be at the Climate House at Tøyen, and maybe the main topics will be climate in the Arctic. We'll see, but you're all welcome back, of course, for that. So thank you, everyone, for participating and joining, and vel hjem.